See? Come on, YouTube. Woohoo, yo! How's it going? All right. Live on YouTube too? I'm doing good. Who, can you do me a favor? Just type like 2 + 2 in chat like that or something like that. I have something that I want to test. Oh my god, it works! Okay. I I I have something that I want to try. God, I'm so glad that works. Oh shoot. Really? It doesn't know how to do that. Maybe try it with that character? Like with the asterisks? Asterisk? Oh, there it goes. And it's coming from me, so it just looks like I'm super smart, right? I need to pretend that I'm actually like writing it. um Oh, they're confused with why there's variables involved here. They have some answers though, so let's look for one that doesn't have too many answers. Something I feel it's, actually, let's look at the answers and see if I have anything to add to these, maybe. Okay, so actually I do have something I want to add on to these. Because it was, the way it's described to me is that t is really just a dummy variable. The function is really just concerned with x. T is just there because you don't want to repeating the same variable inside the integral with the bounds of the integral. It's considered bad form. I couldn't tell you exactly why. I think just to be clear, there's a separation that these aren't necessarily the same thing. Is that f of x is indeed just a function of x, and that t is just a dummy variable for the sake of the integral. I think the purpose of this is to be clear about what parts of the function are actually varying. Only x. I was it took me a little bit to figure out how to do that, but I was really happy once I did. I think it's the coolest thing. There's a bot I made that looks at each message in chat. Or not, I didn't make the bot, but I set the bot up so it looks at each message in chat, and if there's math that it can do in there, it'll do it. Basically. And I have an idea that I want to try if and when Zach raids. I want to like pretend that I'm gonna be a mental math like genius. Too hard to understand. You know, I'll take that too. All right, so I'm a little bit. I realized as I was explaining this that I actually don't have as strong of an understanding of this as I thought. So I'm adding on a few like qualifiers, like as far as I understand. But yeah, you just don't use x inside an integral like this, just so you're clear that only this x thing is actually changing. This you just really want to evaluate the integral to find out what the function is. And so you can't always do that, but yo, Heidi. I owe you a Rubik's Cube solve, don't I? Which I am happy to do. I'll even time it. All right. So there's the scramble. Let's do the scramble. It doesn't really matter. I think back's like that, but no, it doesn't actually matter because it all scrambles it, but I think that's back prime. All right, I do. All right, inspection time. Interesting. My solves on stream have not been as good as my solves when I'm just like doing it alone. A bit harder to concentrate, but that's my excuse at least. Shoot. Oh my god, it's this one. Ah. Oh my god. That could have been such a better solve. For whatever reason, I lost the muscle memory at the end there. Oh shoot, I didn't do this. But yeah. All right, there we go. So, I do F2L for the first two layers, and then OOL and PLL. Actually, is that what they're called? I might even forget what the technique is called, but orient last layer, permute last layer. I believe those are CFOP. Yes. Right. So I think the absolute best of the best might have their own technique that's even harder, but yeah, that's one that I know. Is that what you do, Heidi? Use beginner? Oh, okay. Yeah, I first learned with the Dan Brown videos. There's 7 integers in the solution set. M and N are positive. Let's see if we can figure out what this is asking us to do. Just recently started cubing. Oh, if you only just started and you're under a minute, that's really good. Using the basic method, once I got good at it, I was under a minute, but it wasn't really consistent, and I was still like, I had a lot of room for improvement, I guess. So this, how do you do this? What's the x's? There's 7 integers in solution set. I don't know how you do this. Your record is 38 seconds. Ooh, that's really good. Record is 17. I got very lucky on that solve, though. I got to skip, I think, PLO. That was like back when I was in high school. That was probably like 10 years ago or something, to be honest. I haven't really solved it like too seriously. I just have been solving it for fun every like now and again rather than trying to get better at it. Yeah, the skips are always nice. Do they miss something in this problem? They have check marks. Eh. Oh, that's an annoying integral to verify. Heidi's your mom. Frederick? Oh, okay. All right, I'll try to remember that, Frederick. We've got an imposter among us. Not a ton on here. Sus. Grade 13 derivatives. Okay, now let's go to a different subreddit. This looks pretty answered. I don't know. What is this pattern? I'm not looking at that. 4 subs last stream, not including you? Ooh, that is good. I don't watch it that or my YouTube sub count that closely, but I didn't notice that I broke 100 the other day, which is good to see. Yeah, for whatever reason, my last match stream did pretty well viewer wise, which I'm not complaining about. That is an answer. Let's try ask math. 108. Oh wow. Yeah, I didn't know I was at 108. To be honest, I don't even look at my YouTube numbers that closely. I've been starting to learn the YouTube analytics a bit, but I haven't gotten too like into it yet. In general, my YouTube stream needs to be a lot better. Like I want to get alerts for YouTube and just kind of work on that stuff a bit more. I mean, it'd be very easy for me to see. I just don't care enough to look at it that much. This is not an exponential curve. It's a parabola. Yeah, I'm from California. So I think I have something that I can add to them here. Have the emotes who? Oh shoot! I still need to message you about the corgi emotes. The flag? Yes, the flag is actually. I am from California, but the flag is actually Fallout New Vegas. If you've heard of that game. There's a faction in that game called the New California Republic. And you see it's like a two-headed bear. And so I was like, oh, I'm in California, so I should get that flag. You know, here, let me see if I can actually find the ones that I was looking at quickly. Hoo-hoo. It might not be that hard to find. Oh, there's some cute ones. Oh my god, every time I look at Etsy, it's hard not to buy like every emote. Oh my god. Okay, so there's like yeah, who let me what are those faces? It's like there's those, you know, pretty cute. There's this one that I didn't even know existed until I just happened to look at it now. It dances, you know? There's a different one that I was looking at too that I kind of liked. I can't find it right now though. Where is it? Hey, Yuri. Yeah. Shoot, I can't find... There were, two others that I wanted, potentially. Or, like, one or two others, but... Like, I like both those. Okay, I can't find the others right now, I guess, but... Oh well. I'll look for it more later. I probably should... Shouldn't spend too much time on this on stream, but so I'm gonna look at once Anders gets here, if he does get here. If not, I'll message him. Some theory of probability question from you. I'm not too good with probability. Did you say that I don't remember seeing one from you. Did you post it a different day or something? Oh, and Heidi, or sorry, Frederick, what game are you playing on your gaming channel? The gaming channel is kind of a little bit of everything. It's like I just posted a DayZ video, but I have done Phasmophobia. I don't remember what else I posted to it, honestly. It's kind of taken a back seat recently. Because I'm just still learning to like edit videos, and it's kind of time consuming to do 2 YouTube channels. Oh, well, thank you, Frederick. Oh, yeah, sure, hoo-hoo. I can make you that new account a mod if you're switching over to a new Discord. So yeah, shoot. No, I don't have another video planned right now. I need to get some good like gameplay, I guess. Merci. I know how you say you're welcome in French, but you're welcome in French. Wait, Mercy's Italian, isn't it? Hey, Storm. Did I just... This is Italian. No, wait, is it French? It is. Okay, never mind. What's thanks in Italian then? De rien or de oh my god. So I shouldn't try to speak other languages. Oh, it's grazie. Okay. You're welcome. There you go. Oh man, I just want to know how to pronounce it. De rien. It was nothing. Okay. De rien. Wow. I didn't think it... De rien was pretty close. De rien. I don't have a goal for subs on YouTube, Frederick. I just kind of am seeing where it goes, I guess. I don't have much of a plan. Storm, I said hi. Like, how do you know when to use combinations, when to use permutations? Oh, okay. The simple answer that isn't always simple to apply is combinations don't care about order, permutations do. So with the same numbers, permutations is a higher number because each ordering is a different possibility. 10 more subs than your friends? Oh, okay. I mean, I just try and focus on my on myself, to be honest. Jed? Wow, no one scooped up first until then. What's that, Storm? Oh, I don't know what that is. Jed, can you actually do me a favor? Can you do exclamation point first? Hey, okay, it works for me. Okay. I might try and figure out how to get it so it doesn't say, so it just says one time rather than times. And I want to make like a little like leaderboard too. Hello. Oh, konnichiwa. Okay. Okay, so for this person, well, that's so like, you know, it's not an exciting way to phrase it, Jed. And Frederick, we can see what that is. I this will be the last thing that I translate, because I don't want to just this be you like okay. You like cheese and ham? You have good taste then. You forgot your new account? Oh, all right, hoo-hoo. If you do go for a new account, just let me know so I know to like give it moderator. Maybe some exercise. You want to forget that you must write your thesis? I'm pretty sure I worked it out, but this is a question from Anders that I'm waiting for him to like get here, but it was kind of a fun question. Your thesis, yeah. I'll leave it up on the screen while I put my mug away. Seeing the channel QED, yeah. I mean, honestly, the QEDs are flowing in Pen Center's channel. Here, they're only occasional. Okay, so let's see if we can give this person a good response. So I think they're a bit confused about what they're trying to ask about, so I want to give them a few like resources here. You have an exercise, Storm? Yeah, I'm going to type out a response to this person, and if you have a question, I'd be happy, or if you have just like a for fun exercise. Your questions are always fun, so I'd be happy to look at it. Oh, you can solve the integral? I think I've solved it too, but I don't know if I've done it quite right. I want to wait for Anders to be here though before I talk about what I did too much, so. Frederick, that's a good one for a calculator. It's that. There you go. Okay, so I want to show them vertex form and I want to show them function transformations. And Math is Fun usually gives nice, like, beginner explanations here. Describes a parabola. Exponential function. Hey, InfoFox, welcome in. Kind of the gist of the stream is I take questions from either people in chat if they need help, or if things are slow, I look on the internet for questions to answer. So that's what I'm doing right now. I'm looking at something that this person wrote on Reddit, and I'm trying to give them an explanation. I do dual stream to YouTube as well, so if you hear me talking to someone who's not there in Twitch chat, that's why. Oh, you take f of t equals to t to the a. I was doing fundamental theorem of calculus, and I got a weird answer, but I was able to adapt it to be right. That's probably a better technique, though. Have I watched HP? I assume that's Harry Potter. I've seen the first, like, 4 or so, I think. Yeah, it is pretty. I guess that is completely reasonable to assume that this is some f of t is equal to some power, or some t to the power of a. All right, I guess we have 2 ways of solving it now. Because I just I took the derivative of each side, and I just tried to solve for f of t, basically, or f of x squared, rather. And I ended up getting to your answer, but it wasn't right on its own. A not equal to -1. Yes, that makes sense. Oh, shoot. Who is it telling you the link expired? Ugh. Discord is really annoying with that sometimes. Shoot. I mean, for me, man. Let me get a different link. 1 second. Okay. Sorry, just give me 1 second. And then I want to make sure my existing link still hopefully works. Okay, yes, it does. Good, okay. Okay, back to this. Question. Recommend taking a look at the vertex form of a parabola. That needs to be a link, not just brackets. Which gives a convenient way to define, to make a parabola with a given, a given vertex, which is related to its axis of symmetry. If you then want to take a parabola you've made and move it around, I would recommend you look into function transformations. All right. I think this is enough to get them a start on answering the questions that they asked. Ooh. Differential equations. Ooh, let's see. All right. I hate having to scroll like left and right. Okay. Two chemicals A and B are combined to form a chemical C. The rate or velocity of the reaction is proportional to the product of the instantaneous amounts of A and B not converted to chemical C. Initially, there are 40 grams of A and 50 grams of B. For each gram of B, 2 grams of A is used. Ooh. It is observed that 10 grams of C is formed in 8 minutes. How much in grams is formed in 16, I assume, minutes? Yep. I haven't done one of these in maybe ever. I'm sure I just need to find a similar problem and I'll be able to figure it out though. Differential equation chemical reaction. If you want to get math problems to do as practice, where is the best place to get it? What class are you in? If you were in a calculus or differential equations class, and less so, but still trig and algebra, this site is amazing. It's my favorite site. If you're in a different class, then I'm not sure. But calculus differential equations are the best. Algebra and trig are pretty decent too. for this site. Frederick, Nightbot is a bot that I set up just to kind of advertise my Discord link and stuff like that. So not in class, just want to get a math degree. What were you hoping to study then? Or like what type of math? Because or maybe where did you leave off in math? And you, like, maybe I can tell you like how you could progress. Because this would be a great site to study from. Yo, Zach. Welcome in. Thank you for the raid. Hey, everyone. Okay, now that you guys are here, I do have something that I'm excited to show you all. So, you know, I'm a bit of a genius, as I'm sure you all have figured out, and I've really been working on my mental math skills. So if you guys write any type of arithmetic in chat, like, you know, just like 2 + 2, even like that, I will instantly reply to you with the right answer. Just try me. Hey, Peach Tea. Hey, Braden. Gotcha, Jeff. Zach, I need you to do an asterisk. I don't know what X is. Gosh. See you, Frederick. Easily done. Yeah, come on. Give me a hard one. That's too hard, Jeff. Yeah, come on. This is easy. Harder. Don't quote me on that. I can do factorials. I mean, I can do factorials. This is me. This is definitely me. Hey, Lucky. 700 factorial. Yeah, it's basically infinity. Oh, yeah, I'm Frederick. I didn't set it up in YouTube. Okay, I kind of like ruined my attempt to troll a little bit by how I talked, but I set up a math command, and I was like, oh, maybe I can troll people by making that run whenever someone types math in my chat. So I think I'm gonna turn off like whenever anyone types anything, that exclamation point math thing. Oh, it doesn't know mod. Maybe if you do, I bet you can do percent. 301% 2 or 3. No? No, I doubt I can do integral. Oh, the bar might work. Idiot bot. Oh wait, square root of -1. Okay, you know, no dots. Well, if you think that goes off to infinity, you're just wrong. You know, if I say it's 0.3333 and that many threes exactly and no more, that's just the answer. Proof by authority, yeah. Okay, can it do exponents? Oh wait, it's I filtered myself out. I'd have to do. Oh, it does know exponents. I guess it doesn't know imaginary though. Or maybe? I don't actually know the limits of this thing. Input box, what is an integral? That's a good question. Oh, it doesn't know e to the 2 pi? So I hope you're familiar with a derivative because they're basically opposites. Uh, kind of the yeah, it's not that advanced, Brayden. You can't give it word problems. Or you should give it a word problem that's actually gonna be not a number. Like, doesn't have a number for an answer, then it'll be right. But info block. So the one sentence explanation for this is the derivative is the rate of change, and the integral is the area under the curve. And the area under the curve turns out to be the opposite of the rate of change, basically. Riemann hypothesis proof. So I can tell you an integral just fine, or I can tell you how to calculate one, or both, I guess. But it's it has this fancy like S symbol. Like elongated S, and I'm trying to think like what. Like, I guess when you're asking what is a derivative, maybe what kind of information are you after? Because I don't want to give you like a 20-minute explanation here, I guess. And Lucky, you're asking, what's the distribution of the second highest draw out of n draws of a known distribution with the CDF of F? The distribution of the second highest draw out of n draws. Are you doing a limit PhD? Making it calculate? Looks like it's approaching -3. Man, that isn't my specialty, Locky. I'm trying to think how you would like. The distribution of the second highest draw. Use order statistics? Thank you, Zone, for. Just give me like something to search here. Ignore that? All right. Sure, Storm. Oh, tetration? It actually did it. That's 3 squared squared, right? No. Wait, no. Never mind. That's 3 cubed. Why did it do 3 cubed? 3 to the 3 to the 3? No, I don't know. Oh, wait, no, that is. That's 3 to the 3. And that's what 3 caret 2 is, right? Okay, yeah. I'm not good with that notation, obviously. 1 string 1 plus string 1. I wish it said 11. If you roll a 10d6 and look at the second highest value. In string 1. Yeah, really limit testing this. All right, so I haven't done a problem like this before, Locky. Don't worry about it. All right. Yeah, this might be a little bit too much for me to be able to learn on stream. So I wish I could help more, but I hope that you're able to get an answer somewhere. Storm, you're saying that a function t x, oh, what's happening there? Let me pin it so I have easy access. And then what else do we have here? Solve d by dt of f plus d by dx of I. Ooh. Equals 0. Interesting. Incorrect. I wonder if it doesn't know multiple, like more than 2 arrows. So, oh, I guess these should be partials, right? That. Try to turn this into a geometric problem, really? Oh my god. I think I'm giving you guys like too much power. I'm gonna turn off the auto replying to anything that results in math, but the exclamation point math command will still work. Don't enable that. Okay. Just so that way, oh, really? F of 0, x sub 1, dot, 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 x sub n is equal to g of x sub 1, dot, 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 x sub n. Okay. Oh yeah, I'm using I can streamer. I mean, I'm using StreamerBot for this. They do give a link for the library that they use, or I don't know if it's called a library or what, but oh wow. Whoa, you can do a lot with this. Here's the documentation. Wow, you can do like trig functions and stuff. Binary functions. You can actually do a lot with this. Wow. Okay. Equation to a scalar product between 2 well-chosen vectors. Really? I was do exclamation point though, Zach, or exclamation point math. Dot product? Yeah, that's definitely a thing. Dude, oh, is that E? Oh, that would be E. Yeah. Hey, Bookbinder, how's it going? So we want turn the equation to a scalar product between two well-chosen vectors. Okay. Well, it's going to be the dot product. Well, I don't know if this is well chosen. I don't know if I want to do it like that or... Because that's just like dotted with 1, isn't it? But I don't think that's what we want. We need some kind of cancellations or like, you know, something that like is a bit more complicated than this. Oh, it does the logical evaluation for 2 equals 3? That's cool. You must rewrite your equation with a dot product. Okay. So we need to take this equation, rewrite it with a dot product. How do you... Oh, I don't know how you would write a binary. You might put b in front of the number? Like lowercase b? I don't know, though. I looked at the documentation earlier. It might say, if it's possible. What is... I mean... The direct thing to do is... I don't know if this is... Just making each of those terms one of the like elements of the vector. And dotting it with 1. It's like, I think these are the same statement. I feel like that's not what we... I've almost finished? Really? The meaning of dot product equal to 0. The angle between them is 90 degrees. They're perpendicular. It can do Fibonacci? Oh my god. So this is perpendicular to 1, 1, 1, 1, 1. How does that help us? We're solving for f. Or f is what we want to figure out. Is f? What is the meaning of your left vector? What's the directional derivatives in each of the dimensions? Oh, it does do binary. You got 666. You have to do b dot. Interesting. Look, what is the meaning of your left vector? This is a gradient of f, right? Is that what I'm supposed to say? And the gradient is always perpendicular to that? Play with bot stream? Yeah. Oh, is that doing the floor of the speed of light? What is the meaning of the gradient? It's the rate of change along a given direction, or along a given vector, if I remember right. So for the gradient, no matter what, when it's dotted with that, is always 0. The gradient must be constant. So does gradient f equal anything that's perpendicular with that? Where the rate of change is the bigger. Vector of greatest ascent? Okay. I'm assuming c is the speed of light based off the number that Jeff got. Okay. It's a bunch of constants. Oh, okay. That's awesome. So, okay, so it's not always. What can you deduce if you move the direction of 1, 1, 1? That's the greatest ascent? Or wait, the vectors are, when you move perpendicular. So okay, when we perpendicular to 1 is greatest ascent. If we move in the direction of 1, 1, 1, that's not necessarily least ascent. We're moving along the side of the curve, I guess? Like, we're not changing? The function is constant if we move along 1, 1, 1. Is it the least rate? It's constant. Okay. Okay, so are we, I guess we're saying that if we take the original function f of 1, 1, 1, no. I don't think that, well, is that right? So, I mean, the function is a constant if we consider like one direction of movement. But doesn't mean the function overall isn't necessarily a constant, right? The sum syntax is apparently that. I 1 10 I squared. Like that. It's exclamation point math. Exclamation point sum. Yeah, there you go. 50-50, just like Gauss. So I feel like I'm being slow. I wish I was fresher on gradients, I guess. Then what you can say of... Oh, thanks for the lurk, Zach. What can you say? Welcome back, Frederick. What can you say of z approaching t of x, or z approaching t comma x as you're saying it, plus z of 1, 1, or z, I guess, times, for constant, for fixed tx. The function z? That's going good, Frederick. The function z. Okay, so z is a function. It maps... I feel really slow, Storm. I'm sorry that I'm not getting it. For the function z, I don't know. This doesn't make any sense to me. Hey, Hardlocked. There's I've kind of brought a storm of chaos into my chat because I've just been setting up StreamerBot, and I figured out that there's a way that you can make it do math, and so people have been trying to like break that. Oh yeah, shoot, Frederick. I didn't set it up for YouTube yet. I should be able to though for the next time I'm live. Yeah, sir. I'm sorry, but I'm not seeing like what this last step. I feel like maybe I didn't write it right, or look at the image of f on this line. Frederick, no. For the next math stream, it'll work on YouTube. Look at the image of f on this line. The image of f on that line. So, are you saying that we're considering f of 1, 1, 1? Like, I was wondering if that was equal to some constants like c. But that doesn't really make... I guess maybe not 1, 1, 1, but some when everything is the same? Like that? Okay, let me write what you just said. H of s equals t comma x plus S of 1, 1, okay. Or S times. And Z of S equals H of F or F of H? And look at dz by ds. Well, dH ds is 1, 1, 1. Oh wait, bot down? You guys finally broke it? The first 10 billion numbers? Oh no. Hopefully it has a hard limit on runtime. I don't know how that works. It might just have cut itself off. Like if I, okay, yeah, I think it cut itself off. I assume it's a hard limit to how long it'll let it run. So it just, it won't just, it just didn't respond, but it might be okay. It's a self-hosted bot, so and my computer isn't melting down, so. Or maybe it'll eventually respond with it's some the model. It'll probably be NAN though. So I assume if you go out of the maximum integer that it can do or whatever, then it'll tell you NAN. So, well, I feel like I'm getting back to like gradient of f dotted with that is 0. Is dz by ds 0? Is that what that is? Compute and you'll see. Well, okay, df ds, what is that? I mean, s is just a scalar, isn't it? I don't know what to do with df to ds, I guess. Really? Isn't this just chain rule though? I don't see what I'm missing. Oh, I guess f of h. Like, are you saying that that's what I'm missing? Uh, I don't really remember Frederick. It's been so long since I bought this. Dayan? Oh, it's hard to see on the screen, but D-A-Y-A-N. Yeah. Oh, okay. Well, we still don't know what f of h, like we don't know what f is, so I still don't see what we do with this. Oh wait, well this is where we have to know, this is a constant, right? Because f along this line is 0. Is that it? And when you derive a constant, is it? Well, I still am getting 0. It's false? Hmm. Storm, I'm sorry. I just don't know. I'm not good enough with this math. It's because of the t and the x, I guess, or like... The derivative is the sum of the partial derivatives. So, but when we have the composition, are the variables t, x, and s, or are they the original t, x1 to xn? That's what I don't really know. d by dtf. Okay, so it is back to the original, I guess. d by ds h of s. Plus between the sum and the... I guess a plus there? H of s. Okay. d by dx sub I f. F of h, it looks like. d by ds of h. I hope I'm interpreting that right. In the d by ds of h, it is more precisely the d by ds, the ith component of h. I guess you'd see that as h sub I? I don't know if that's quite right, but braided. You're right, H sub I? Okay. Hey, Anshuman, yeah. Trying to see what that spells out. I see went. Thank you, Anshuman. And let me focus on what Storm is saying. Can I give you 10K? You have probably better things to spend your money on Schumann. I don't have, my channel isn't big enough for super chat though. Now for D by, and for the D by ds of h before. I mean, I don't like. I'm in California. I do have, I guess, that link. If you actually, is it that through Stream Elements? I can take donations if I'd actually. Is it tip? There. So if you want that, it's there, but I don't really like to advertise it. I'm just here to help people. And for the D by ds of h before the sum. Compute and conclude. So for that D by ds of h. Okay, is that where we get 1? Because that's a constant. That's s to the power of 1, and that's our constant, I hope. And that equals 0, so you just get that? I don't know. And that's all equal to 1? So you get the sum of those? Compute? Okay. And I'm saying that's equal to 1, I guess. So this is 0, I assume? By this fact up here? And just get that summation? But I don't know what that is, I guess. Is that supposed to be something? You must have a scalar, not a vector. Yes. Because I'm saying that each of those h sub i's are going to be 1 as a scalar. And in Schumann, it hasn't shown up for me yet. It might just take a minute. I'm not sure. And you definitely don't have to do it. I appreciate the thought, but if it doesn't, if for whatever reason Stream Elements isn't working, then I don't know. Um, wait, that one? It's just a one? I'm really confused then. I thought that one would be general. Oh, I guess it... Like that? Hey, Eyes Hazmat on YouTube, if I'm saying that right? Now look my equation in the eyes. Well, this is the same thing that's up there. It's equal to dz by ds. So dz by ds equals 0? Does that help us? Oh, Aisha, if I'm saying that right? Angle geometry? That's kind of a general question. Or probability? That's also a general question, I guess. Do you have a specific problem? What can you say about z? Dz by ds equals 0. So z is a constant? I hope. Okay. I can try, Aisha. It's kind of a depends on the purposes, though, I guess. Let me get through the end of this question. Evaluate in 2 good S. S equals 0 and S equals 1? Like, oh, I don't have that set up, Brayden. I'm still kind of working on my commands. Hopefully in the next few weeks that'll actually work. I'm trying to figure out what my commands are going to be. So I don't have a good response for that yet. I was going to do like z of 0 equals f of h of 0 equals f of t comma x, I guess? And then maybe z of 1? I don't really know what to do with this, though. F of tx is what you want. Think about the g. I don't know, Storm. SPQ, I guess the question was to solve this differential equation. And I guess there's a geometric solution involving thinking of it as a dot product. I've been a little bit lost though after basically this point. Oh, it's Happy Valentine's Day, Brayden. I see. Well, I mean, I don't know. Z of G? You have to compose it? I'm confused because Z is just like single variable. I don't know what CFS is. Isn't it just C? I thought we said that Z is a constant. I know, Storm. I need to start looking at other questions. Can you kind of just like tell me what the answer is? I definitely don't know how to solve this. I'm completely lost. S equals negative T? Okay. So maybe it'll be more clear if I write it like this. Like that, I hope, is equal to, I don't know, I hope I'm not going completely off the rails with that. Is that even remotely right? Do you have the stream muted, Brayden? Yeah, that's a problem. That is good. Okay, I'm glad I didn't do that completely wrong. And Aisha, I'm trying to bring up some kind of probability explanation that I can go through with you. But it's kind of a huge topic. We just say introduce me to this, so I'm not sure if I'll be able to give you. Like, I can't just do a whole lecture, because I'm definitely not prepared to do that. It'll be in another like minute, but I've been thinking about it. I guess Khan Academy is probably a good place to start. Z of 0 equals f of t of x equals z of negative t. Z of 0 is equal to f of t of x. Okay, yeah, that's what I saw. Which equals z of negative t equals f of 0x equals g of x. Okay. Then f of t of x equals g of x. So the t isn't really there, right? Or the t is just always 0 in original function f? Is that the conclusion, Storm? Or is there more? So I want to kind of like move on at this point. So if you can like, in time you do not move. Yeah. Like it's not dependent on time, according to what Storm is saying, but I do want to like talk a little bit about probability here for Aisha. I don't want to spend too much time on this one problem. I was hoping it'd be a little bit shorter, I guess. So Aisha, since you normally ask a specific question, I'm just going to go through kind of like a couple pages in the Khan Academy thing, because I don't know what you want to know, I guess. Oh, that's too big for me to link it. But can you explain probability? Okay, I was a little confused about that part. SPQ equals g of x minus t. Okay. So, Aisha, I hope I haven't missed you, but if you are still here, generally for probabilities, oops, I minimize it. What you often want to do is to get the number of desirable outcomes divided by the total possible outcomes, and that's just your probability right there. So if you flip a coin and you want heads, that's one desirable outcome out of two total outcomes, which is heads or tails. So that's why flipping coins is 1/2, which is 0.5, 50-50. If you're rolling a dice and you want to roll a 1, that's one desirable outcome out of 6 total. And sometimes they might say, like, what's the probability of rolling an even number? In which case there's 3 even numbers, 2, 4, and 6. So 3 desirable outcomes out of 6 total. Which comes down to 50-50 again. And Aisha, are you still here? So I haven't seen you type something in a minute. You are here? Okay. Good. I just want to make sure that I wasn't explaining it to an empty room. Gosh, I wish you would give the lessons in text on the site, so it's easier for me to like go through. Honestly, like a probability, like an example or something. Yeah, Peach T. I saw there's an example for or I saw there's a transcript for that one video, but you're right, it's not the same as an article. Some probability. Okay, card problems are usually good examples here. So what is the probability of drawing at least one ace from a pack of cards on 2 draws if you do not replace the cards between? Okay, I think this is a good question to start us off with. Leave it up there, I guess. Hey, Jan Schumann. So yeah, Storm, I'm sorry that I didn't really get to the very end of this problem, but I just have people ask me questions and I don't want to keep them waiting for like too long. And I guess I'm too slow to do it quickly. Wait. All right. So our example is, what is the probability of drawing at least one ace from a pack of cards? So I'm going to rephrase this. If you draw 2 cards, what is the probability? They're saying at least one ace. To me, it's a bit more clear about what they're asking. Okay, so a deck of cards has 52 total cards and has 4 aces. 52 total cards and 4 aces. So the first time we draw a card, there's 52 cards in the deck, and we want 4 of those, or any one of those 4, but there's 4 good outcomes and 52 total outcomes for our first draw. But we get 2 draws, and so we could get it on this draw and we're good, or we can get it on the second draw. Actually, oh, no. Actually, wait, this is a little bit more complicated than I'm thinking, right? So there's actually, how are they phrasing this? Because there's 2 different, there's a few different ways you can interpret this, actually. With probability, the wording is very important. I see. Okay, so you're always drawing 2 cards? Okay. Well, let me phrase this a bit differently. So you're always drawing 2 cards. If you get an ace on the first draw, you don't stop. So there's 3 possible scenarios where we win here. I just say like good scenarios. Our first one is we draw 2 aces. Second scenario is we draw ace, then not ace. The third scenario is we draw not ace, and then an ace. There we go. This is the way that the website is intending it. I was interpreting it a little bit differently, but probably the problems are a little bit weird like that. That interpretation is important. So we need to get the probability of each of these scenarios, and then because we want any of them, like we take any of them, we're going to add all these up. Got it? Okay, good. So the probability of drawing 2 aces, let's just look at that first. So on our first draw, this is what I was saying with 4 out of 52, because we have 4 aces out of 52 total cards. We don't mind any of those 4 aces. But since we're drawing twice, in these it's kind of like 2 things happening at the same time. You might call it an and. You draw an ace and you draw an ace. When you say the word and things are independent, you multiply. And if you don't know what independent is, maybe let's not go that far in this question. But for the sake of this question, if you want 2 things to happen simultaneously, you multiply. So in this scenario, we've already drawn our first ace from the deck, which means now there's only 3 aces left and 51 cards total. And this dot also means multiply if you're not familiar with that. So this is the probability for drawing 2 aces, because the first draw is 4 out of 52, and then that means an ace is taken out of the deck. So the second draw, we have a 3 out of 51 chance of getting an ace. Now for the second scenario, we draw an ace and then we don't draw an ace. Well, that means our first draw, we do get an ace. So there's 4 scenarios there out of 52 cards. Again, same thing. And then not an ace. Well, we still have 51 total cards in the deck now, but we want everything except for the other 3 aces that are left. So I'm going to do 51 minus 3 is 48. And then the other scenario is we don't draw an ace and then we do draw an ace. So if our first draw is not an ace, the chances of that are 48 out of 52. Because there's 48 things that aren't aces in the deck. And then there's still 4 aces left, so we do probably drawing an ace now is 4 out of 51, because we did take one not ace card out. Okay. And now, since we don't mind any of these 3 scenarios happening, so you take all 3 of these probabilities and add them up. And this is at the time where you punch it into a calculator. Unless your teacher really likes making you do fraction math, I guess. And this probability is from scenario 1. This is from scenario 2. This is from scenario 3. And so let's look at what the website was saying. So I kind of cheated and glanced over the website to make sure that I was interpreting their question right. Let's see how the website worked it out. I think it's basically the same way. So they break it down into scenarios just like I did. So yeah, for ace and ace, they say they simplify their fractions. They say 4 out of 52 like I did. And then they say 3 out of 51 like I did. Okay. And then ace and not ace. And Storm, I think you're right. This website does make a point where it's not always like that, though, for other situations. Don't want to be all possible combos. If you draw 2 cards from a deck, you have 52 times 51 possibilities or combinations for those cards. I get a little bit fuzzy. I guess the total combination is 52 times 51, and then the numerators represent the desirable scenarios out of that, I guess. Aisha, how do you know the denominator is 52? That's a good question. So a deck of cards has 52 cards total, and you can get any one of those cards, so it's your total number of outcomes. And if you it's kind of the unfortunate thing with probability classes is you just kind of have to memorize that a deck has 52 cards. They don't usually tell you that, unfortunately. So if you don't already know that, it's something that you, in most classes, they just expect you to remember that, in my experience. Could be permutation. Oh, maybe, yeah. So let's make sure the rest of them match. So they say 4 out of 52 and 48 out of 51, right? Then 48 out of 52 and 4 out of 51. Okay, good. So my numbers here match with theirs, even though they wrote it different. And so your final answer is 33 out of 221, which is work for a calculator. What did I say it was? 33 out of 221? So the final answer is, well, okay. If you round it off to say like 4 decimals, 0.1493 or 14.93% chance. In SPQ, you're probably right. Yeah, that is easier. I wouldn't show that to someone that way because the question was just like, can you introduce me to probability? So that's how I'd introduce it to someone, but that is a simpler way of solving it. 59 over 51 times 52? Sure, Storm. No. If you combine, you should get 33 over 51 times 52. Actually, no, that's not simplified, is it? How do you unsimplify a fraction? $220 over that. Okay, yeah. I guess we can check that. Oops, that's not division. Did plus instead of times. Wait, that's still different. Yeah, Aisha, I guess that's how you should, if you're just learning probabilities, that's how you should think about problems and how you should approach them. Sorry, my explanation was kind of like a little bit like, going like, oh wait, no, it's actually this, but I hope that's a nice like way to get started with probabilities. If you have a specific question, please let me know. It was good? Okay. I'm glad I was able to help you out then. Yeah. Okay, I was looking at that chemical reaction one. I got beaten to it though, because that was a while ago. Oh well. So I don't see any I hope I didn't miss someone asking a question in chat. I don't think I did. Sorry, I'm just sorting out something on my Discord. Okay. I guess we can look for some questions on the internet. Hi guys. I'm good. How about you? Thanks for coming by. So we did reply to this one, basically asking when you have a function defined by an integral, why do they use this t instead of x? And so I gave them kind of the best explanation that I could come up with, which I don't think was perfect, but at least serves its purpose. And someone replied to me. You did it wrong? Oh, okay. No worries, Storm. Okay, this person is just adding on, which is completely fine. You don't need to do that, Storm. It's just arithmetic. I make arithmetic mistakes all the time. Oh, are you out here, Storm? All right. Well, I hope you have a good night. Sorry that I had to like tap out of your problem, but it was still an interesting problem. I just had to start helping others. So I appreciate you. Yeah. I feel like being good at arithmetic is like more of a party trick than a measure of actually being good at math. I have written a graph of the function's points. Are they talking about a table or an actual graph? I think the question's a little bit vague. I'm not sure how to best help that person. As an answer. Hey, Emiliano, how's it going? I think we're going to switch over to the math Discord because I don't see any other questions on Reddit. Brayden, are you here? Did you wave to who 3 different times? I'm just looking at my Discord now. Like, usually one wave is enough. I'm doing good. Thanks for asking. Just on the prowl for some math questions. This Discord usually has a lot of them. I can't always help with them, and sometimes things get a little weird, but yeah. What's the equation? Oh, okay, Brayden. No. No worries. I was like, it's only like a rule, like you're only allowed to wave once. That's hard to read. I was like a little like, oh wow, you're really enthusiastic about waving, maybe. I'll be if you give me an equation, Emiliano, or at least tell me what type of equation you want to see, I'll definitely like work through it. A book about number theory, and one chapter is dedicated to people who are great at mental calculations back in the 1800s stuff, but since computers. Oh yeah, I guess before computers, it is more of an important skill. Like I think about in stats, like a Z table. Like I assume those Z tables were first made before computers existed, and that someone just calculated that stuff by hand, which sounds really tedious. The equation to determine the length of a rope. Oh my god, it did it! Wait, it actually did do sum 1 to a billion. That's hilarious. Like an hour later or something. Emiliano, I think I still need more information. I'm not sure. Like, the length of a rope could be a lot of things, I guess. Like, do you have a problem that you can copy and paste, or could you like if it's easier to screenshot. If you could maybe take a screenshot from the PDF and put it in my Discord. Took me long enough? Yeah. That'd be the easiest thing for me to see. People did a bunch of TD's calculations. Yeah. Finding digital pi. Oh yeah, they definitely did calculations for that. Oh man, I wonder if Jeff is still here. That's really funny that it actually did it. All those were wrong after some point? Oh no! Oh, that's the worst. I think there's a Chinese mathematician, like, in ancient times, or I don't know how ancient, but sometime in history, that used like a 10,000 sided polygon to actually like calculate an approximation for pi. I don't know if he made a mistake though. And hey, Oak Spirit, welcome in. Anyone here know any good differential equation solvers or any general types of differential equations you're really... Oh, okay, a few things, I guess. A free one with steps I'm not aware of. Oh, well, oh no, Symbol Lab, I don't know, do they take it back? So, I don't know if you're not aware already, like, Wolfram Alpha will at least tell you the answer for free, and they'll show you the first step or two. But I assume that you're aware of that one and that you know that it's not free to get the full steps. Oh, really? I thought Archimedes was first, but he didn't make it as exact. I might be mistaken. Oh, okay. I didn't remember Symbol Lab. I think they started not doing all the William Sheng, so I haven't heard of that person. Is there a different differential equation solver? I don't have a resource I can give you about how to solve them, but Sim says for $3 lifetime. Oh, interesting. Yeah, I don't have one offhand. Does this give steps? Oh, no, it just gives you the final answer. What if we give it a harder one? No, it just tells you the final answer. Okay. Yeah, I don't know of a good solver. I can tell you a site for resources for how to solve, or for like how to solve them yourself. For Fidget and half of Google. Oh, okay, yeah. Then you've looked harder than I have. What I will say is that this site gives fantastic explanations and example problems of differential equations stuff. So I will just help you learn how to solve it, but an actual solver I'm not aware of, I guess. I have some, you can kind of cheese Wolfram Alpha, because they'll give you the first step. If you were to give it like, what, y prime plus x, y equals e to the x, just, you can get the step-by-step solution and just keep giving it whatever the first step is. Or like whatever the last step it gives you. So I've sometimes done that in Wolfram where I'll just like look at this part and then I'll put that up in here. And then look at the next step, but that's not ideal, obviously. And it's a little bit harder to do with differential equations because the steps aren't as easy to type in, but that's kind of the best that I got for you, I think. Yeah, I mean, even today, we don't need to be that accurate with pi, I don't think. Oh, we got optimization. You have and repeat of fencing. Oh, Emiliano, hey. Sorry, I didn't see that you joined. Let me... I'll make a little thread for you, Emiliano. And I added you in it. Oh, okay. So that's the equation for arc length. Do you want an example problem done with this, or do you just want me to explain like why this equation is the way that it is? I guess like maybe what is your question about this? To get from that equation? Oh. Get from that equation to this one. So what was the original, like... Where does the x come from? Yeah, these feel like not the same question, Emiliano. Uh... Like, I'm not sure how these are connected. From this graph to that formula? Are you given the equation for this graph, or like the function for this graph? Because if you are, then we can get something done here. You don't have it. Oh no. Well, how do we do this then? Is this supposed to be like, we're supposed to, maybe we don't need the original function? I think it's going to be the result of some arc length integral down here. And maybe I'm thinking we have to get the hypotenuse from 2a to a. And that's our dy by dx somehow? I'm not really sure if that's right. Well, oh. Oh. Wait, so you said this is part of a PDF? Could you actually, can you maybe post the PDF? I don't normally like things look through a PDF, but this might actually help in this case. So we can see how things are, like what the order of the stuff is. Because this is definitely strange. No, man, I'm sorry for the yawns. No worries, Emiliano. I might still be able to figure out what it's saying. Okay. Demonstration activity. Only the first team that presents the demonstration, the something demonstration of the explicit form, legibly and with something. I don't think this is important to the question. Consider, I'm tapping out of that. Let's go to Google Translate. Considering as a basis the following image that presents a parabolic curve. Okay, that's important. This is a parabola. Furthermore, let the equation determine the length of a chord. Okay. Okay, this is coming together now a little bit more. Can I translate this entire page? No. Okay. Consider the following equality as support. Hey, Anders. Really? So this is a parabola. If a 2a difference in x makes an a difference in y, that seems weird though, right? Shouldn't it be the other way around? F of 2a equals a. Yeah, I'm trying to figure out like what it means for a parabola though, right? That seems, I guess if you have a fraction, that might be true. If a is less than 1. Oh, okay. I guess that works, Jeff. Thank you for pointing out that example. Oh, and Emiliano just came to the same conclusion. Okay, good. Or Emiliano already said that they got to the same conclusion. Okay. So do we even need that though? We can just let it be A. Maybe. So what I'm... And Anders, I think I figured out how to do your problem. Once we've helped Emiliano, I'd be happy to talk about it. Need A equals 1. Yeah, because I was wondering, like, we need to demonstrate the formula still involving A, so we don't even need the equation of the parabola. We just need ax squared, I think. So if we take... I guess we can see if this works out. Y equals ax squared. Does this integral work out? And actually, don't they just give you the answer to the integral? Is it x squared over 4a SPQ? If you plug in 2a though, oh, you do just get a. Okay. But, well, oh, Wait, why doesn't Jeff's thing work? It only works for a equals 1, but SPQ, your thing works for any a? Is that the trick here? I don't think the exact thing that I said is right. Okay, so Emiliano, I think if we do have y equals x squared over 4, or we can say, it isn't kind of much. Y of 2a is equal to 4a squared over 4 is equal to a squared. That's only true if a equals 1. So it's actually, in this scenario, a can only be 1, so that's not a very general formula, I guess. Let me see what SPQ is saying. SPQ is instead suggesting y equals x squared over 2a. Hey, Timo. And in this, y of 2a is 4a squared over 2a. Or sorry, y over 4a, not y over 2a. And this works for any a not equal to 0, I guess. Oh, you're Symmetry. Okay, I was wondering, like, hey, that's Symmetry's name. Nah, you can have as many different YouTube accounts as you want. Okay, so Emiliano, I think we need x squared over 4a. for the function that we're starting with. So if you're on board with that... Oh, hey, Brian. Thank you for the raid. Welcome in. How's your stream? Glad to see you back at it. Okay, so I do think SPQ found the right formula that we want. We were just x squared over 4a, because this is true for whatever a you want. And so now if we do our arc length formula, it's integral root 1 plus derivative dx, like this. And using the formula, the simple geometry proof, oh nice. And so with this, we want to manipulate it to get it into the form that was given. Like we want to make these two things match, which they don't quite yet. We want the x to be isolated. 1 plus x squared over 4a squared dx. So we get the x to be isolated by factoring out a 1 over 4a squared. Dx. And then this 1 over 4a squared is just a constant. It can come outside the square root and outside the integral. So it gets square rooted on the way out, so it becomes 1 over 2a times the integral root 4a squared plus x squared dx. And now this form matches that form, and we can use the formula that are given. First day back? Well, welcome back. Hey, Daniel Nasser on YouTube. How do you find the rank of a matrix? My linear algebra isn't that strong. It's something, I think you have to reduce the rows and see how many distinct rows you have. Well, good at Cosmolano. I'm not that good with matrices. Linearly independent columns or rows. So don't you have to reduce it if you want to be sure? Unless you just know in your head. So Daniel, I'd say that you figure out how many linearly independent rows or columns that you have. Yeah. And they say that this one, it's rank 1 because you can kind of just tell by mentally checking that the second row is twice the first row. So your rank is 1. But the identity matrix is easy to see that the rank is 3 because these must be linearly, I shouldn't say it's easy to see, but you know, these are linearly independent. That makes sense? All right. Yeah. Sorry, my linear algebra is super strong, so I can't give you like a super amazing explanation, but that's kind of like my quick explanation. Okay, so for Emiliano's problem, we want to use this fact. Oh, that's actually, either way, Cosmolano, isn't it 1? Because the columns are also going to be multiples of each other? I think I wasn't really looking at it. Why is the x in this formula? That's so weird to me. I guess you take the maximum or the minimum, I don't know. I don't. The fact the X is really throwing me off on this formula. I don't know what you're supposed to do with that, Emiliano. Oh wait, okay. And sorry, I was missing what you were typing on Discord. But this is the form that you need it to use that formula in some way. X over 2 equals A? Does it? Calculus of variations? Not really. No worries, Daniel. So, Anders, this was something that Emily, I was supposed to go out in my Discord if you want to see like the conversation that's happening. But the prompt that they were given, this is basically the entire thing here. So thanks to SPQ, we figured out that this parabola must be x squared over 4a. And we have to demonstrate that the arc length of this parabola follows this formula. And they're given this fact, so they don't have to do the actual integration, I guess. So I got it into this form, but this formula is super weird to me. That's only true for a equals 1, I think, was the issue. So like I looked at that possibility up here. If you actually plug into a squared, so this is only true for a equals 1, right? Or 0, maybe? This one seems like it's always true. Let me see what Emiliano's typing in the Discord. I think we're just supposed to solve it with a generically, for a parabola that has these proportions, I guess. Well, I guess a could be anything. That's not 0 with that form. X over 2 is the only term that can give that. Because in the second formula, look how to a is factorized. X over 2 is the only term that can give that. So x over 2, oh, they're saying this a must be x over 2. I don't know, it's kind of doesn't really sit right with me, I guess. I don't know if I can be on board with that, Emiliano, but if you at least know where to go from here, I might leave you to it. Because I could solve this integral just without, by like ignoring that formula, but I feel like you're not supposed to do that. That's my interpretation, Anders, because they're only given that graph and that it's a parabola. So I don't think you're supposed to know exactly what a is. You just have to show that this result is true. You don't need to do that to integrate? Okay, yeah. Yeah, you don't need to actually get the integral of this, Emiliano. So I'm not sure, we could, like, it's not going to look exactly the same, but you could apply that you don't know what to do from there. Okay, if we do... I'm not really sure of that either, Anders, I'm going to be honest. That would make sense, I guess. But they don't really give bounds. Oh, maybe that is the trick. Oh, maybe that does come from the bounds. Okay, Emiliano, I think Okay, that's a good call. I think we're integrating from 0 to 2a based off the picture. And that's where your x equals 2a thing comes in. So if we use the formula here, the root m squared plus n squared, I'm going to take 2a as x, I guess. I don't know. 1 over, let's see how this works out at least, and maybe we can modify it if it doesn't work. 2a over 2. So I'm right now, Emiliano, I'm plugging into this formula right here with the integral that I got. Where's the form? Okay, root. That's m squared, that's n squared. But n is x. Should I just leave it as x? Like, maybe I leave it as x. 4a squared plus x squared plus m squared 4a squared over 2 ln x plus root 4a squared plus x squared. Evaluate this from 0 to 2a. Let's see how this works out, I guess. 2a over 2 becomes just a. Root 4a squared plus 4a squared is 8a squared plus 4a squared over 2 ln 2a plus root 8a squared. Then we have to subtract off any zeros. That one's 0. This one is something. Four over 2 is 2, so 2a squared ln root 8a squared. Yeah, I agree, Anders. I'm really confused by that. I've been trying to figure out how to deal with that. And sounds good, Jeff. So yeah, I'll definitely find this problem confusing, and I'm trying to reverse engineer what they want you to do. Just as a warning. So I might get to the end here and figure out that I'm wrong. So let's try and simplify this a bit. That's a squared 2 root 2 can we do anything with that? That becomes 2a plus 2 root 2a that's ugly. Minus that. I don't feel like this is right. Well, it's nearly right. I have 2 root 2's though. It's actually pretty close. It's actually, ooh, am I right? Because we need to get to this last line, and I'm not too far off. I guess let's keep pursuing this. Should that be 8a squared though? This should be 0. Or it should be not 8a, it should be 4a squared. That's what was making me, that's part of why I thought I was wrong. Because x equals 0 for this one, so it's just root 4a squared. So that becomes ln 2a. So multiplying the 1 over 2a in now, you get a root 2 plus a ln back to the 2l, 1 plus root 2a minus a ln 2a. Okay, and then you factor the a back out. Is this the final answer? I think it matches. Whoever did that, I thank you. Okay. It should be x's? Okay. I might have made the right assumption then. That does match. Hell yeah. All right. Thank you, Andrew, for the suggestion on the balance of the integration. So yeah, Emiliano, I guess that's how you're supposed to do it. I don't blame you for being confused, because I was also confused on this problem. Did I lose you at any point here? And I see you typing back in the Discord. Oh my fucking god. Thank you so much. No worries. I do need to erase this in a second, so I'll take a screenshot and post it in the Discord maybe, unless you're okay without it. So I want to, oh wait, I'll look at Jeff's link quickly and say yes or no, and then I'll look at Anders' problem. All right, got the screenshot. Oh, you have a screenshot? Okay, cool. I'm gonna erase this on the board then. 92 times 97? Oh no, Aura. Okay, here, look, I'm hoping Jeff's question is gonna be a quick yes or no, so let's do that, and then I'll do the quick math, and then we'll do Anders' problem. The path of least time given these conditions. Oh, was that? So were you asking me about calculus of variations earlier, or was that someone else? Oh no, that was Cosmolano. That feels like a host of variations thing though, isn't it? Not that I really know what it is. I don't really know how you do these problems. I haven't seen one of these before. I can maybe learn it, but I don't know it offhand. All right, so BC, that's where you're leading with it? Oh, okay. I mean, I'll leave it up. So you want 92 times 97? Let's do 100 times 92 is 9200 minus 3 times 97. Or 92. 3 times 92, right? No? 100 times... Wait, I'm doing this wrong. 100 times 92 minus 3 times 92. Yes. 3 times 92, 6, 276. 9200 minus 276 is 8,024? 8,824? Oh. Oh, that's an annoying multiplication to do, Oakspirit, to be fair. I corrected myself at the last minute. I guess I'll call myself Ray, but I feel like I said 8,800, but I'm gonna say that I was right, because I did correct myself. That is a neat trick, Brian. 100 minus 8 times 100 minus 3. You do 100 squared. My brain's crapping on me. Minus 300 minus 800. Plus 24. Yeah, that's a nice way to do it. Okay. Trying to sneak into variations. Oh, okay. Yeah, that's a much simpler way, to be honest. All right, I'm sorry to have kept you waiting, Anders, but we can look at this one now. So I'll show you the way that I did it, but I think I made a mistake or something and I still ended up with the right answer. And then I brought it up earlier on stream, and Storm 2 Pain, I think, gave a better way of doing it. So my first instinct when I saw this was to do fundamental theorem of calculus and do some manipulations from there. And it got me to the right function, but it was plus another function, which would give you the wrong answer if you still included it. So I just chopped it off and checked that the thing that I had afterward works. Okay. So we have the integral from 1 to x squared f of t dt equals x cubed plus c, x greater than 0. Okay, so I derived each side because this just screams fundamental theorem calculus to me. So you get 2x f of x squared, if I did this right, minus f of 1 equals 3x squared plus c. Oops, not plus c, just 3x squared. And you can take x equals 1 here and figure out what your f of 1 is, I believe. This step felt a little bit sketchy, but I didn't see what was wrong with it. And from this, you know that f of 1 equals 3, supposedly. I was a little bit weirded out by this step, but I just kept it going. And now we just isolate f of x squared. So you add 3, divide by 2x. We're given x is greater than 0, so we don't have to worry about division by 0. And now we take f of, I said positive root, you could also do negative root, I guess. And you get 3x plus 3 over 2 root x equals f of x. But if you verify it back with the original question, this plus 3 over 2x doesn't work. Chain rule, Peach Tea, yeah. So if you did try and plug this back into the original integral, 1 to x squared, 3t over 2 root t plus 3 over 2 root t dt. This term over here messes up. This integrates exactly how you want it to get you the x cubed. This just screws everything up. So I just chopped it off. Because the only goal is to find the function. So this is how I found it. That's the same thing as t to the 3 over 2? No, wait. you rationalize that denominator, what happens? Well, the function is like this. I just need to write in a different form. I'm going to chop off that part already. So I feel like I did something wrong because I did get that extra part. Is that just 3 root x? Oh, or 3 over 2 root x? Wait, why is that slightly wrong? Or is that right? No, wait, it might be right. Let's just verify it. Oh, let's just integrate it to verify, I guess. 3 over 2 root t dt. That's the exponent of 1/2. You add 1 to it, and you divide by that new exponent. So the 3 over 2 is multiplied by 2/3 and goes to to 1. That's the word I'm looking for. So you get t to the 3 over 2 from 1 to x squared, which gives you x cubed plus 1. So f of x is equal to I said 3 over 2 root x and c equals 1. That's how I solved that problem when I first looked at it. I'm still weirded out by this part over here. I don't know if there's a way that I could have avoided that, but that's how I solved the problem when I first saw it. Something that Storm suggested, though, is that just by looking at it, you can know that f of t is a polynomial. And you can take f of t equals to t to the a and solve it for a. You got lost at the middle? Okay. I'm sorry that I just kind of like plowed forward. Okay, so basically the idea is I did fundamental theorem of calculus, or I derived each side so I can use fundamental theorem of calculus. Just trying to go back through it. This is what I got for my derivative. I just arbitrarily took x equals 1 so I could figure out what f of 1 is to get rid of it. I found that f of 1 equals 3. So plugging 3 back into up here, I should say this is like, I guess this is a little aside in this box. So from this line going down to this line, I just plugged in 3 for f of 1. And then I isolated f of x squared. I guess, okay. And so once I did isolate f of x squared, I just took the root of x in the function, the positive root. Although you can do the negative root too, I guess. Just to get what f of x should be. And I kind of prefer to see it split up as 3 over 2 root x plus 3 over 2 root x, which is also f of x. And so that's what I got when I isolated f of x, but I found that this messes, like this gets you the right answer and this is extra and just doesn't work. And I don't know why that happens. Pre-comes with a square root. I don't see a reason why you can't do it. I don't know. Like, I feel like you can do it. Like, you could phrase it a bit differently. Like, you can say u equals root x and treat it as a transformation and do everything in terms of u. Oh, and yeah, x is positive too. Okay, I didn't think of that, to be honest. I'm glad that happened to work out then. But yeah, I got that for what the function, like what f of x is, but then I didn't think that felt right, so I went back to the original and I tried to verify it. And I found that this term here was just straight up bad. So I just chopped it off and took only that term. So that's how I approached the problem. I feel like I shouldn't have gotten that if I did it right, but I don't know. Because this one on its own definitely doesn't work either. Does it? If you integrate 1 over root x, you get 2 root x. So you'd end up with 3 root x. And then you plug in x squared. No, you wouldn't get a cube out of that, I guess. The choppity chop method? Yeah. Yeah, 3 over 2 root t is the answer? Yeah, I mean, I said x, but t is, I guess maybe t is better to use, but 3 over 2 root t and c equals 1. For the way that I did it. So I kind of like, I don't know what you would even call this. But I somehow ended up with the right answer, at least. I do think what Storm suggested is probably better to do. Just knowing that f of t is a polynomial with one term. I'm kind of curious to follow it through. I doubt Storm is still here, but if you integrate that, you get 1 over a plus 1 t to the a plus 1 from 1 to x squared. 1 over a plus 1 x squared to the a plus 1 minus, plug in 1 there, you get 1 over a plus 1. C equals -1. Oh, no. You're right. C is -1. I didn't do the subtraction for the lower bound. What is the third line from bottom to top? That third line, that was scratch work. I wouldn't pay attention to it. I was getting confused on x over root x. It's not important for the actual problem. Does this get us the same answer? So we'd want this coefficient to be equal to 1 to match that form. And that exponent to be 3? Well, these can't both be true, can they? No. How would that work then? Oh, wait, no. You can... I think you only want to care about that one. The solution that I threw away. So, I mean, the entire solution that I got was this thing, but this part, it just doesn't work. I noticed that I got the right, I got an x cubed when I integrated that, but this was just an extra term that wasn't even needed. So I just was like, oh, well, it doesn't work, so. I'm gonna roll as one. And there's, let me just erase this. So what I did is I thought that was my answer, but it didn't feel right, so I tried to verify it with the original statement. I found that that term got the x cubed, but this term was completely random and didn't fit that format, so I just chopped it off. I went from this being my f of x to just that being my f of x. So that's why I feel like I did something potentially wrong. It did get there in the end, so I'm like, I don't know if it's that bad or what, but... Was there an intended way to solve this problem? So, like, aside from Storm's way that I was trying to work out on the left. Which I think I'm nearly at. You'd have to factor out, that's 3/2, which becomes 2/3. Factor out a 2/3. And so whatever you had originally, you have to multiply by 3/2 to get rid of that, I guess. So I guess this method would work too. Maybe you should put a constant in front of that, like a b. I guess it gets the same answer, but it's a little bit weird at that last step. You couldn't solve it? Oh, okay. Yeah, Cosmo, what Peachy was saying is, was it 100 minus 7, 100 minus 3 is equal to 100 squared minus 3 times 100 minus 7 times 100 plus 21. Oh wait, 8. Doing that as a mental math trick. Oh wait, Jeff, are you still here? Your sum to a billion thing, it worked. It just took like an hour. Yeah, like it just randomly put it in chat at some point. I was in the middle of explaining something, so I couldn't, I don't know where it was now, but yeah, it did eventually run. If you have 37 different marbles in the bag, you grab 2 at random. How many different combination of marbles can you get? Brayden, that is 37, choose 2. It's just, you know, simple mental math. Oh, you found a peach tea, nice. So yeah, Brayden, 37 marbles, you grab 2 at random. 37, choose 2. Oh, 666. That's why you're asking me that question. That's funny. Okay, yeah, so yeah, Andrew, I didn't realize you didn't actually know the answer to the question. So that's the way that I did it on the right. Storm suggested just knowing that f of t is a one-term polynomial in solving for the exponent. I think they both work. Interesting problem, though. Storm's way is probably just better, to be honest. My way feels like there's a little bit of a sketchy step. The entire thing was sketchy. I feel like there's a different situation where it might not work. It's not a polynomial? Oh, you're right, because it's the exponent is rational. Sorry, when I say polynomial, I just mean the variable to a power, I guess. Is there a generic term for that? I don't know. It should be your variable raised to a power, I guess. Oh, and thanks for responding to Emiliano's question. Yeah, no problem. Sorry I did like a bad job of explaining it. Or explaining like what I did, but thank you for the question. Okay. Yeah, I don't know about that. Did someone already answer this? Yeah. The key to the question was if possible. That part of it did kind of scare me. Or it kind of makes me tempted to just say, oh, it's not possible, and leave it at that. Hey, Noreen over on YouTube, how do you do fractions with different denominators on a number line when the line is already set? Oh, like how do you compare them? How was today's meeting real analysis? It was good. It actually, it was cartograms. I don't know what a cartogram is. But we wasn't able to make it, so it was actually just me. Thankfully, Merriweather hopped on for the first half hour or 45 minutes or so. So we were able to work on some of the problems together, and then it was just me and Zach for the last part of it. We started going into derivatives, though, and I thought it was a really interesting meeting. So we first reviewed the extreme value theorem, and then we worked with the limit definition of a derivative. And first just computing things with it, and then proving that differentiability implies continuity, which I'm very glad I had Zach for, because I was going to go off on not the wrong path, but a more complicated path, as it turns out. So if I was just left to my own devices. Well, Zach and Zone Ranger helped. Oh my god. Okay, so Noreen, let me draw the situation that I think you're describing and tell me if I'm right. So you have a number line that's already set. I'm gonna guess maybe, you know, you have 0 over here. I don't know why I'm drawing it like that. You have 0 over there and maybe 10 over here. And do you need to place fractions that are like maybe 5 over 7, 13 over 5, maybe a bit of a bigger one, 24 over 6, like fractions like these, you need to place them somewhere on that number line? And so probably I'm going to go over to the real analysis stuff after this question. Use the devil's calculator, you have to get 666. Oh, interesting, Brayden. Differential derivatives are meant to make students think calculus is hard. Honestly, the one definition was a bit weird at first, but that wasn't... I was able to wrap my head around it after not... Or I was able to wrap my head around it, I guess. Limit definition feels intuitive. Yeah, it's like I think I had the benefit of a good teacher who explained it as like a tangent line. And that kind of, it didn't immediately get it, but it sunk in over the next like few weeks. So Noreen, I'm not seeing you saying yes or no here. So I'm just gonna go with the example problem that I set up here. And if the problem isn't how I described it, please let me know. So if you have to place these fractions somewhere on the number line, if you don't have to be too exact, let me actually draw the numbers between 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It can be a little spaced out, I guess. 2, 3, 4, 5. Okay, so if you have a number like 5 over 7, I would kind of do, if we're allowed to be approximate here, the top is less than the bottom, which automatically means that this number is less than 1. That's kind of a trick that I've learned after doing math problems a bunch of different times. So we know that 5 over 7... actually, I mean, maybe something that's better to show is that you could actually divide these as well if you want to be a bit more exact. So 5 divided by 7 is like that. You need to go to decimals because you can't multiply 7 by something to get 5. So then 7 times 7 is 49. You get 1. Do another 0. 1, 7, and so you can keep on going. This will, you know, go on forever, but 0.71 is about 5 over 7. So 5 over 7 is somewhere around there. Similarly, 13 over 5, we could just divide them as well. Now there's a different way that I'll show you to do this as well. So this isn't the only way to do these, but this is, if you have a number line like this is probably the way I might do it. 5 divided by 13, you can go in 2 times, you get 10. 3, bring a 0 down. 5 goes into 36 times. So 2.6, so 2.6 is somewhere around there. (13 over 5), and then finally 24 over 6. 6 actually goes into 24 4 times. So this one is a nice clean number. So this is just 4. So if you're given a set like number line with the tick marks are like given like that, I think your best bet is to actually do the division and find the decimal. But you might be in a different situation because I'm not sure. If you just have to compare these fractions, you can just get a common denominator as well. So if you have to do like, let's look at this example. Like, is 5 over 7 greater than 5? Or is it greater than? Is it less than? Or the equal, I guess, is another possibility. And we can do this comparison. We can figure out which one of these scenarios it is by getting a common denominator. So one denominator is 7, the other denominator is 5. Their least common multiple, which I hope you know that term. If you don't, the safe bet is to just multiply by the other denominator. So if we're working with 7, just multiply by 5. Remember, you're not just allowed to multiply by 5 for free. You can only multiply by 1. So multiply by 5 over 5, which is the same thing as 1. It's just in disguise. So 5 times 5 is 25. 7 times 5 is 35. And then now we need to get a common denominator for 13 over 5. Same trick, multiply by the other denominator over itself. 7 over 7. 13 times 7, what's that? Get a 91 over 35. Now there's a common denominator. You can compare just the numerators. So 91 is bigger than 25. So we'd say 91 over 35 is greater than 25 over 35. And that agrees with the decimals that we got earlier for each of those. So I hope that answers your question, Noreen, but please let me know if not. What is that weird hopping down thing? That's fair, Peach Tea. We actually, yeah, you were there for that. You saw me have a little bit of trouble actually proving that power rule. It's kind of unintuitive. Secant line gets closer and closer. Yeah, exactly. That definition worked for me. The secant line becoming a tangent line. Brayden, I don't know if I'm going to do a problem from you, but we can look at it. Because you give kind of hard problems that aren't ones that I enjoy doing, to be honest. Or like, they're not the area of math that I'm interested in, I guess, is a nice way of saying that. Oh, that's weird. It feels like there's a bunch of rules that I have to learn that I don't want to learn right now, to be honest. Awesome, glad Emiliano got help. Whoever that was there got deleted. See, I'm sorry, Brayden. It's a little bit like too much for me right now. I kind of rather work on the real analysis stuff. I was almost ready to change function to a given variable. Yeah, that's fair enough, Cosmolano. All right, let me bring up the real analysis stuff that we were doing. Okay, so during class, we got all the way down through number 5. And we left 6, 7, 8, all the rest of these. Real math, he's got math zoned. This just feels a bit more helpful for me to learn, I guess. Yeah, you don't really need the limit definition, I guess, in your calculus class. Oh God. There's a previous prompt like building up to this, and now you just have to straight up do this limit. That one might be interesting. I don't even do. I might want to do the ones above it first, though. Someone sent these. Ooh, interesting. Oh, I know. For this one, I've actually seen it. It involves doing this limit, and that's why L'Hopital's isn't valid here. Anyway, let's not get too far ahead of ourselves. Let's look at let's start from 6. Let's go green, I guess. All right. With limit definition, just normal power rule. Oh, that's funny. Do functions have to be continuous? They would probably have to not be continuous specifically. Function that is not differentiable at a single point. There's many different examples we could pull. We could go for discontinuous, or we could go for piecewise, or both, I guess. Or absolute value. Absolute value really is just piecewise, though. I'm just looking at the rest of the questions to see if there's going to be sin x over x. Is that not differentiable at a single point? I don't know. At x equals 0? Oh, yeah, I guess so. That is not differentiable at exactly 2 points. Sine of 1 over x? Well, I don't imagine sine of x over x is differentiable at x equals 0 either. It's not defined there. It's not differentiable at a single point. I'm curious, like, there's a lot of things I could name. I'm just wondering if there's one that's better or worse for me to choose. I'm gonna have to prove it, I guess, which is kind of the issue. How do you prove that it's not differentiable? We have the fact from number 5 that if it's differentiable, it is continuous. But we don't have the reverse direction. Show the limit doesn't exist. Oh, okay, yeah. I like that. When you say it like that. So for A, yeah, we could do a step function. We could do absolute value. Either one would work for this. Either way, my argument, I think, would be the same. Equal to 1 for x greater than equal to 0 for x less than 0. Um, my claim is it's not differentiable at x equals 0. Because the limit as h goes to 0. Oh man, we haven't really done, we actually have done right and left-handed limits. H goes to 0 from the right, f of x plus h minus f of x. Well, I guess we would plug in 0. Is that right, though? Wait. I'm sure it's not continuous. Wait. This isn't... Not h versus 0 from the right, just h... Okay, look. I'm getting my terms mixed up here. No, I don't know if this is... Wire stress function for a C? Would this be easier with the other definition? This might be easier with the other limit definition. It's more clear to me what's happening. Limit as x goes to 0 of f of x minus f of 0 over x minus 0. And for this one, I think we do want right and left. Maybe you do want right and left for the h as well, and that's what I was getting confused on. So f of x, when it approaches 0 from the right, is 1. Wait, we still get 0 minus 0 on the bottom. That makes it kind of a pain. I should shift this function just to make it easier. Wait, either way, we're going to get 1 though, right? Or we're going to get 0 on the bottom. How do we deal with that? I guess... Oh wait, maybe this is okay. Well, no. Derivative of 0 almost everywhere. Yeah, maybe absolute value of x is better. We can still do our same construction here, though. Maybe we do want the h now, though. Okay, yeah, we do expect that. You're right. And so, case one, these are both positive, I guess. Or they're both negative. Is that right? Yeah. Okay. I guess that, yeah. Do some algebra magic for plug in 0. Yeah. I still don't know how you do it for that constant function, I guess, but this example is a little bit easier to deal with. Abdo Salam over on YouTube. Hey, how's it going? There's non-differentiable at exactly 2 points. So, I keep on wanting to do a set function. We could do... I don't need to limit myself like that, though. I can do just a piecewise function that's not a set function to make my life a little bit easier. So we could say f of x equals x for x less than 0. It equals x squared for 0 is less than or equal to x. Oh wait, these are actually equal at x equals 0. I should take different endpoints, right? Well, either way, the derivative is definitely not going to be right. The derivatives would have to be equal at that point, and they're definitely not. Are they? No, yeah, they're not right, because that'd be 1, that'd be 0. Two x and 3x. That'd be easier for computations, yeah. You're right. And Abdo, C can use tangent. Ooh, that's a neat idea. I was thinking some kind of trig for that one. I hadn't gotten that far yet. Tangent is a great call, though. And so, yeah, just for background, Abdo, this is like a real analysis kind of like practice problem set that I've been kind of working my way through, just so you know what's happening with the stream. Welcome in. Just say less than 1. So yeah, these are like, just by knowing calculus, we know these all never have the same slope. So we do have to prove it, though. As h goes to 0, f of x plus h minus f of x over h. Oh, Omar, thank you for the follow. Okay, so this, we have to go into cases again. So if we have to go cases as I define them up there, I guess, when x is less than 0, we have the limit as h goes to 0. We have x minus f of x over h equals 1. X 0 less than or equal to x less than 1. Limit sh goes to 0. Now our function is 2x. Yo, thank you for the sub, Omar. For the prime, I really appreciate that. Are you did you just come over from YouTube? I see you have the same Salem in the name. Either way though. Yes? Okay. Well, hey, welcome in. Thank you so much. Your Abdo? Okay. Well, I appreciate you. 2x plus h minus 2x over h. This does come out to be 2. Then when x is greater than or equal to 1, yeah, and I just realized what you meant before with permeates differentiable everywhere else. That's a lot of work, but I feel like I understand it. This will be the exact same thing. It's already kind of a lot of writing. It's 3. So it's not differentiable at these like breakpoints. Differentiable at. Actually, this kind of proves it that it is differentiable everywhere else. X equals 0 and 1. Okay. Now for infinitely many non-differential points, we do have what Omar said, which is tangent, because that's just, it has infinitely many discontinuities. There's something else that I would like, sine squared, I think would fit the bill as well. Because sine squared has corners, right? Absolute value of sine x, yeah. So mine immediately went to absolute value sine x, but I thought sine squared might be simpler, but honestly, probably not. I just kind of want to see what sine squared is and how it compares to absolute value sine. Oh wait, it is smooth? Okay. Oh, you're right. I don't know why I imagined it'd be the same thing. Okay, you're right. Thank you, Zone. I was picturing it really similar to absolute value in my head. So, tangent, it would work too, but I don't necessarily know where that's. I feel like I'd be more confident. Actually, well, we have to actually prove it. Improving sine's derivative is a task for later. Or proving sine's derivative is not trivial. Is there a different function that I can think of? But I just realized, like, I gotta prove whatever I'm saying. And we don't have sine x over x, that limit being equal to 1 automatically. Like, that's a proof later on in this problem set. Is there something without trig functions, I guess, that has infinitely many discontinuities? Like, we could extend this, like some kind of infinite piecewise function, I guess. And just have like some dots involved. That feels kind of like cheating, though. Infinitely many. I feel like trig is the only way to go, but trig involves doing things that are later on in the problem set. So maybe I will actually just move on and deal with the trig problems that are later on the problem set as they come, because I feel like that kind of just... I feel like I can't do this without trig functions. I can't really do it, at least, without making some kind of like gimmicky... like without like really like forcing it. Properties of one sequences also apply to derivatives. Yeah, that's what I was like, infinite piecewise function. That's the other thing I was like thinking of. I guess it, or basically extending out like that piecewise one with like nx for n equals 1 to infinity. I don't know how you really show that. I don't know if induction would work with that. Maybe it would, but I think I understand the concept at least, and I don't really want to write it out again. I assume we can use the limit definition here to do these identities. I guess let's try it and find out. Actually, let me zoom in a bit more. I don't want to go through every last one of these, but let's at least try the first one or two and see how they go. The later ones, I bet, are going to be more difficult. Like quotient rule. Ugh. All right. It does dry super fast speech sheet. I don't really get why. D looks suspicious. Oh, wait, that can't be right, can it? 1 over f of x is 1 over f prime. Oh wait, is that just the quotient rule with one? There might be a simpler version of the quotient rule. It might actually be right. Just D might it looks a little weird, but maybe. I guess I should start from the top though. Let's start with A and we'll work our way down. So d by dx of f of x plus g of x. I guess we want to start with one side and get to the other side. I think either way, this will be pretty clear from the limit definition, right? I think if we apply it to that side, it will be like they would each get their own plus h's. And we can split this up to be two individual limits. So this one I don't think is too bad. So to me, that's enough for A. The proof in the book similar to that. It looks like D. Oh, okay. Yeah, it feels like D would build into E. All right, so B, d by dx cf of x is equal to cf prime x. This mixing of the notation with d by dx and f primes kind of, it makes me have to like stop for a minute to parse what's actually happening, but it's probably for a reason. X plus h minus cf of x over h. Yeah, this one won't be. You factor c out of the numerator, and you can take it all the way out of the limit. So I would say these first ones are not bad at all, and I'm sure the later ones will be much harder. All right. Our interconnection got so you can barely go to the stream in 360p. Oh no, that sucked at SPQ. All right, so product rule. I think that's where things are going to heat up a little bit. I've seen the proof for product rule before. I don't remember it. So I'm going to be flying blind. Oh, you know, you combine C and D to make E, I bet. In some way. All right, so I feel like for this one, you're gonna have to do some funky plus minus stuff. Is my instinct, at least. Like someone gets something that's factorable on top. It's like we want to get f prime times g and then g prime times f. So we need some way, like we want f of x plus h minus f of x in parentheses times g of x somehow. And we just try and force it and factor g of x plus h out the way that it is. I don't think that really helps us. Add in a fancy 0. Okay. I've got the right idea, Zone Ranger. Now, which fancy 0 do we want? If we did like should I just start trying things? Well, limits of the function of derivatives. Oh, okay. F of x. Oh. Okay. Thank you, Zone. F of x, g x plus h. I should have guessed it'd be something like that. I was trying simpler things in my head, hoping it'd be simple, but this is reminiscent of some other limit properties that we've had to prove. And I should have, I forget which one. Like I think it was literally like the product limit. You do something that's just like that. Okay, and so how does this help us? We want to take these two can go together, and then these two can go together. I see. Okay. So let's rearrange this. G of x plus h. I want this one to have this one, so yeah. And this one goes with that one. I hope. Over H. Wait. Man, I can fit this on the last line here, right? So we factor the g of x plus h. Wait, no, I'm doing this wrong, aren't I? Well, I guess h goes to 0. I guess I'm doing it right. Yeah, I think this works out. Over h plus, as h goes to 0, factor out f of x from this one. Yeah, this looks right. Prove using epsilon delta? Oh no. I imagine that's not possible, but I feel like it might actually be possible with some insane proof. So this g of x plus h, it's just going to become g of x, because h is going to 0, and you don't really have to worry about it, I don't think. That's what I got confused on with whether, like what that plus h would influence, but I think you're allowed to just let h be 0 there, so I think I'm okay with this. Thank you for the hint. There's Zone Ranger. The g of x plus h approaches g of x. You talked about it today. I was just literally plugging in 0 for h there, but maybe that's not the best. Well, I guess it's, if I were to break it out, I guess I was really doing the product of the limits. I don't know if this is what we talked about today, but that's what I was doing in my head to mentally justify this. And when you just let h be 0 there, you get g of x, and that's the definition of the derivative. But I don't remember what we were talking about today that might make me think about this differently. Because I don't think we did that product identity. Why can't you just let h be 0? There's a reason. H is a sequence heading to x. Trying to remember what discussion that we were having. G is differentiable, G is continuous. Oh, okay, I see what you mean. You're only allowed to plug in H for 0 because it's continuous. Okay, that's where you're going with that. Okay, thank you for that. So it is related to that idea with like HB sequence heading to X, but I guess that was like part of the proof. Show that f is differentiable at X implies, or if and only if there exists a function defined in some neighborhood of X. Hey, Jose. Math. Oh, okay. And so we're given up here that they're f and g are differentiable, and we proved in prompt 5 that differentiability implies continuity. Okay. SVQ. This is a function defined in some neighborhood. Sounds like faint or a different way of saying continuity. If I'm reading that right. G in this way, multiply them. I don't quite see that way, but I always get the way that I just did. So, because little h isn't actually 0 lives in a quantum mechanical world. Ugh. So, I guess D looks a little scary here. What's going on with D? It is a typo? Okay. What is it supposed to be? Because I thought it might actually be right if you did the product rule with f of x, like for part E, if you took f of x equal 1, you would get something that looks like that, but with g of x. Oh, like that? Just doing literal like power rule and chain rule. I'm gonna send a Discord message to Zach just so this typo, if it is a typo, I want it to be caught for section 2. Let me. It's a trap. Now the first time I've tried to prove something that's false. Where is Zach? In my Discord. There. Okay. Message Zach. What do you see? You break math. Yeah, that's a good point. E is also a trap? Really? Oh, it should be g of x squared. Good catch, Stone Ranger. But otherwise, E is good. I was trying to figure out what D should be and do that question. Okay, I was wondering if this was something with a reciprocal would require your inverse function. Oh, is it supposed to be the inverse? Interesting. Yeah. Jeff, that's the other interpretation of the -1 exponent. S of x equals x. Oh, I don't know. How do we go about, like, actually, do they prove it right here? What's happening down here? Y equals f inverse of x. Right, this is x equals f of y. Differentiate both sides implicitly with respect. Oh, they do it like this. Oh, the second link is more like Zach's question? Okay. Do you have a x becomes dx by dy? Oh, I guess that makes sense. Oh, it's this right here? The derivative of the inverse function. What's the a and b here? Oh, the a goes with the y value. The b is an x value. Interesting. That's what I think I'm just going to look at what they're saying here rather than trying to prove it myself, maybe, but... f is differentiable. Its inverse is also a differentiable function. Sneaky. Oh wait, they don't actually prove it. They're just saying what the process is. I guess we could try to prove it. I don't know where this is going to go. I assume that was Zach's intention with this question, so let's at least take a look at it. F of g of x equals x, and you differentiate both sides. That could be something. Actually, I'm just going to erase this stuff on the right side. I don't want to lean all the way over to write on the left. So if we're going to rewrite d to mean d by dx of f inverse of x, the pre-image, no, is equal to 1 over f prime x. Let me just make sure that is what the formula was. Yeah. Well, I could be more clear and say f inverse of y. That's probably a better thing to write. So I remember my inputs are different. And so, Jeff, you're talking about composing the function with its inverse and differentiating. Well, we haven't done the chain rule. Actually, essentially the chain rule isn't on this list. I wonder if there's a reason why. Yeah, this feels like something that you would want the chain rule for. Like, I like your approach, Jeff. I feel like that maybe, is there a way to do it without that, though? Like, we just set up our good old definition. Can we do anything with this? We do have that the composition of two functions lets you bring the limit inside. Should we just prove chain rule first, I guess? It feels like we would want that here. Or maybe I'm just gonna pretend like we have the chain rule, maybe. This one, it has me a little bit curious. So do you want the inverse on the outside or the inside? I guess it doesn't really matter. Well, let's do the inverse on the outside. So I can say f of x. So if we differentiate, well, it's to write it differently, but it's fine. So f prime inverse of f of x times f prime. Oh wait, don't you just manipulate it from here? Well, you still have the f of x on the inside of that inverse, don't you? F has to be on the outside? Yeah, I guess so. I guess we can still say it of x and just not be too worried about it. Was one. So we want to solve for that. So we divide by that, but why is f prime of f inverse of x equal to f prime of x? Maybe I shouldn't focus on this one too much, because I don't even know this is actually what Zach intended. It'd be very tempting to just divide by that, but then that doesn't really get you where you want to go, I guess. Come with a fog joke? Oh, yeah. So I don't know exactly like how you deal with that, but if you divide by the first thing, you get it. Well, you get f prime of f inverse of x. F inverse of x is equal to y. Oh, peach tea. That makes it make complete sense to me. Okay, thank you. F prime y, because they have different inputs. All right. Great call. I should do saves. Peach tea, you get a save. Jeff, you get a save. Oh no, is the bot down? Zone Ranger definitely does. Oh, okay, no, just being a little bit slow. Users recircle the site with a typo since you derived that from C. Would you? If you took g of x equal to 1 over f of x squared? Oh wait, Zone didn't get a save? You guys doing it too quick for the bot. There we go. D was supposed to be reciprocal with a typo. So you could derive that from C. Yes, BQ, that is a good point, because we haven't done chain rule, and this relies on chain rule. Oh, maybe you can manually prove that derivative for the composition, Jeff? That could be it. So SPQ is, well, I mean, so the term that you're saying just supposed to be their derivative of a reciprocal? I can't, but maybe you can. I mean, I don't know exactly how that would go, but maybe. Like, we want to prove that D, I think that Jeff said what it would be earlier, is, do you do power rule on that? Like -1 over f of x squared? Well, that's chain rule again. So, I don't know. How much with E unless it's... Yeah, peach tea. It's like, this also is doing chain rule. But it is chain rule in a specific scenario? Maybe let's try it. Let's just set up our limit and see what happens. Because this definitely would build into the next one. No, wait. Yes? F of x plus h, yeah. Over h. That's not a very pretty thing to work with. So what do we want? We want a -1 over f of x squared. So that feels like we should get a common denominator here. No, well, that doesn't help with the common denominator, does it? And then we need the limit definition of derivatives somewhere. I guess let's try getting common denominator. I bet we're going to have to do some fancy zero thing, but before we go that far, that's where the my sign comes from, I bet. Over h? Yeah, I mean, we can take this, prove this in a vacuum without knowing the chain rule. Like, if you take that as a fact, or, you know, you just prove this without worrying about the chain rule or where, like, the right side came from. Continuing then fudge around. Maybe. I'm kind of tempted to take this f of x just out of the limit entirely because it doesn't care about h. I feel like that's probably not the right move, though. Or maybe that's premature. So let's keep it where it is. I think at this stage, we need to look for a fancy zero. Ratio between change in f and change in x, really? I don't know if it requires that. I don't know if I want to go down that proof road. if we were to do... Oh, wait. Am I making this too hard on myself? It feels like we're actually nearly there. Just if we use the limit products. We want factor a negative sign from the numerator. We want to take out this f of x and the f of x plus h. Minus limit h goes to 0. Maybe this is it. This doesn't seem that bad now that I realize this. Over h. That's f prime. That's when h goes to 0, that's 1 over f of x. Okay. Squared. F prime x. Okay, I'm happy with that. Okay. It's gonna be, oh, the music stopped. What am I gonna play? Let's go this, I guess. Why not? All right. Let's try the quotient rule. I assume we're gonna need this fact. Because this is near the quotient rule, but we're gonna have a function up there instead. Like this is like a quotient rule, but if your numerator is 1. I imagine... Well, I don't know if we're going to use that fact directly, or if this is just like a similar technique. I'm going to have to plug it in and see what happens. Dude, I just spray this thing every time now, I guess. That's just my life. Okay. Similar trick to the inverse one. F of x times 1 over f of x equals 1. You have the Leibniz rule? I never heard of the Leibniz rule. What's that? Is that the integral rule? I assume it's not. Part C? Oh wait, over here on the sheet? For that? Okay. Leibniz law? No two objects have exactly the same properties? I think that's not it either. Or at least that I didn't have indiscernibles. It's a defining property of derivation. That there is the saying like the derivative is unique or something? I have a hard time interpreting this. Like, I'm assuming this is something about being unique, I guess. That's the only way I can think of that this would apply. But I guess derivatives themselves aren't really unique, since the constant of integration is a thing. I don't know. Linear operator that satisfies Leibniz law? Oh, okay. Fair enough, I guess. Oh, let's see that. That might be more helpful. What does this bring me? Oh, wait, product rule? Oh. I know this is also called Leibniz rule. Interesting. I'm going to that one. Okay. All right, let's try our hand at quotient rule. Derive the numerator first. I should do it in parentheses. I like saying g squared. I'm okay with saying sine squared of x, but I'm not okay with saying g squared of x. All right. Let's see what our element looks like this time. Okay, so this feels like it's gonna be similar to the product rule. We're gonna need to fancy zero. I guess I said it last time too. Let's start with the same way as last time and get a common denominator. And then I bet it turns into something like a products rule. Once we get it all into one fraction. Let's put the h there, I guess. So this looks a lot like the product rule on top, right? Or it's really similar to what we have for the product rule. In the bottom, we can do the same technique as part D. It's not quite the same as a product rule, though. It was f of x plus h, g of x plus h. Like the x's and the x plus h's were matched. But we'll hopefully still be okay. I think we can safely take out the denominator as its own limit. And just work with the numerator. Well, most of the denominator. So, fancy zero. What kind of fancy zero? Well, there's our minus sign. Should we go for... Well, should we go for maybe plus f of x, g of x? Like, we can investigate this fancy zero. Oops. I don't know if this is the right one. But it feels like it's pretty close to what we had last time. Yeah, that's how fractions work. Don't worry about it. How would that factor? We would have to match the negative with the positive. We'd factor the g of x out, and we have g times the derivative. We match that one with that one. We factor the f out, and we have f. Oh, hey, that works. I guessed right. Okay. We want that term. Over h. H goes to 0. We said factor the g of x out of there. Factor the f of x out of there. We do need a minus sign, which we're going to get here, it looks like. For h. Sure I'm not missing anything in chat. Okay, you guys are talking about something that's beyond me. Just fine. Say negative split up into two limits and you got your answer. Oh, wow. There we go. All right, that gives us what we want. That's f prime x g of x minus g prime x f of x over g of x squared. All right, got it. I'm kind of, I didn't think I'd be able to do all these, but with a little bit of help, I was able to. So thank you guys. Let's look at number 8. Oh gosh, this is where things are gonna really heat up. Oh shoot, you guys can't even see that. Peach Tea, yeah, Zone Ranger pointed it out. That should be G. So I mentioned that one to Zach as well. Hopefully it'll be bright for section 2. So we just have to straight up prove the sin x over x limit, or, you know, Zach uses h's, but let's look at prompt 9-9. So I'd love to, if I can do it without looking it up, that'd be pretty cool. I looked at the proof before. I kind of remember that you like sandwich it or something like that. Yeah, you do this like triangle. You consider the unit circle, I think. Do we have anything above here? No. So it's probably more helpful to look at this before we look at the one before. Or, you know, it's more, before we can do this, off the top of my head, I can't do that. So we should see what hints are being given with 9-9 here. So how does figure 9.1 show that sine of x is less than tangent x? But nope. Thinking about the areas of triangles and the areas of sectors may be helpful. The areas of triangles and the areas of sectors. Is it? Sine of x is less than x. It's less than tangent. And like here, x is the angle? Wait, is x the angle or the length of the short side of the triangle? I was assuming x is the angle, but it's a little bit of like offset. I think x must be the angle if we're taking the sine and the tangent of it. And PhD, I would think radians, but probably probably maybe it's not relevant. I guess it'll only be relevant if we talk about the sector, which I guess we should do. So this circle sector, that's an eighth of a circle? Well, it depends on what x is, I guess. X is also the length of a certain arc. Right, with a unit circle. Thank you, Sophie. Okay. See, oh, okay, so that's why we have a unit circle. So the arc length is the same as the angle in radians. Right. So the area of the sector is the same as the angle in radians. The first triangle is contained inside the sector. The second triangle goes outside the sector. So when we take sine of this angle, I guess we're taking our hypotenuse as 1? Because that's the only way that triangle is going to go right at the edge of the unit circle. So I guess that's okay. But, well, sine of x isn't the area of this small triangle, though. Sine of x is the ratio of the sides. Yeah, Jed. Well, are they? Well, they're made from the same, like, they have the same angle, I guess. You know, drawn on top of each other. I think so, because, yeah, these two sides on the right are parallel. Oh, wait. I didn't realize that that problem was right there. We have, so, oh, interesting. Angle, angle, angle? Yeah, that's how you would prove it, because the right sides are, or all the sides are parallel, I guess. treat the two inequalities separately. It's clear that a certain length equal to sine of x is smaller than the length of the arc. When the hypotenuse is 1 especially, it's just this or the opposite of the angle. Okay. Certain area equal to tangent of x is more than the area of the sector. So sine of x has to do with the length, but tangent has to do with the area. Tangent is sine over cosine. So tangent of x is this equal to a certain area. Well, sine of x is just the opposite side. Cosine of x is the adjacent side because we're taking our hypotenuse as 1. But we're doing sine x divided by cosine when we do tangent. It's still the area of a triangle, I guess. But not the obvious one. So you're reading the little footnote there. The areas of triangles and the areas of sectors. Hey, vegans. Yeah. This is like a basically a study quote question that is building out to proving this limit in part B. Certain areas equal to tangent. X is anything, I think. X is not equal 0, but it can be less than 0 as well. I assume the same picture would still apply for a negative angle. It wouldn't be true for 0? Right, yeah. I don't think we mind that this is false for x equals 0 because we're gonna end up doing this limit anyway where we can't allow x equals 0. For everything else, I assume it works. I haven't actually tried it, but it's not. It's actually you get to the right answer, but for the wrong reason. It's a common mistake. But the proof for the derivative of sine x involves proving this limit. So you don't know that the derivative of sine x is equal to cosine x until you've already proven that this limit is true. So if you use L'Hopital's to do this limit, it's circular logic. It's a weird like exception to L'Hopital's. It does get you the right answer, it's just for the wrong reason. Circle with unit radius and some lines on it. Maybe I need to actually draw the measurements for this, because I'm really not seeing this right now. I feel like I need to actually work out what some of the numbers here would be, because we do know some of them. Okay. Taylor series. The Taylor series also requires deriving it though, doesn't it? Draw it a bit bigger. The actual proof of it requires geometry like we're doing here. As great as it would be to be able to use Taylor series or L'Hopital's, you just can't. Because they all require the derivative to already be known. Okay, so we know this length is 1 by nature of it being a unit circle. We know this length is 1 for the same reason. It's x over 2? Oh, really? Pi r squared theta over 2 pi. R equals 1. Oh, you're right. It is x over 2. Okay. I'm being messed with the theta versus x thing, but it's okay. So vegans, what Sophie or Edabriofer is saying is that if you do the derivative sign with limits, as h goes to 0, sine x plus h minus sine of x over h, this limit requires the same limit that we're trying to prove. So that's where the circular logic like comes into play, because before you've even proven what the derivative of sine is, you at some point during that proof have to figure out this limit before you know what the derivative actually is. So that's why it's like it's a tricky situation that I don't know if it applies anywhere else, but to this situation in particular, it applies. And I'm sure if you Google it, you'll find like some more explanations to actually like draw it out more. Okay, so what else do we know here? We know the right side of the small triangle is sine of x. Tangent of the big one. Well, I guess for the same reason we know that tangent is the big one. Because tangent is opposite over adjacent, and adjacent is 1. The area of the large triangle. Oh, okay. That's a good point. And the small triangle is sine x over 2. No, it's not. Never mind. You can Pythagorean theorem your way around that. Actually, isn't it? You could get a cosine for the bottom. Never mind. That's probably the most important thing. Well, actually, oh, that's the Pythagorean identity. Okay. For that smaller length. I don't know if that's actually important, but we do have it there. So I guess, but the area of the sector is x over 2. The area small triangle is 1/2 sine x. The area of the big triangle is 1/2 tan x. Now, it would be great for, so like, I think it's clear that the small triangle is contained within the sector. And, oh, I was looking at the entire sector, but it's that's our sector that we actually care about. So this is where our inequality comes from, where these are all areas. Okay. So 1/2 sine of x, the area of the small triangle, is certainly smaller than the area of the sector from there to there, x over 2, and that is smaller than the area of the big triangle, 1/2 tan x. And then you multiply the entire thing through by 2. Okay. I get it now. I was like, I get that part now. I don't get the entire proof, but I do get that part of the proof. So what we've done is we have sandwiched x between sine of x and tangent of x, and we also know that sine of x is less than tangent if we want to short circuit that inequality. I don't know how we're going to use this. I guess let's try plugging into our limit definition. So, okay, I feel okay with this. Let's erase it, because all we've done here is just proven that, like, fact, and now we get to use that fact. Divide all sides of the inequality by sine of x. We would get cases because when x is less than 0 but close to 0, we get negative values for the sign. And we get positive when we're on the right side of 0. Oh wait, we're not trying to do the derivative. I keep on being in derivative mode, but it's less than x. Oh wait, I see what you mean. Just to divide it by sine, you get 1 is less than x over sine x is less than sine over cosine. Like that? and then you flip it. I don't know if we have to worry about the cases where things are negative, but x greater than 0. I'm just not going to worry about that, I guess. We can just take x that's greater than 0. Oh, and then we now we can do the limit. And we squeeze it. Because cosine, we know what that is going to be. 1 is greater than the limit as x goes to 0. In vegans, I'll try to explain a bit more about cosine of 0 is 1. Do we need or equals to here? Shrimp between two policemen theory? Yeah. Yeah, if we're gonna do squeeze, I mean, we're not losing anything that we did before if we just put in that or equals to. Because otherwise it's just a false statement. All right, well, here, let me try and explain a bit more about why it's wrong to do L'Hopital, specifically when sine of x over x approaches 0. But, let's just do it on the board. Okay. Because I think now we've done this, I can actually... So if you want to prove, it's actually one of the tasks for the real analysis class anyway. D by dx of sine of x is equal to cosine of x. If this is the problem that you're trying to solve, vegans, and we have to use our limit definition of a sine. Or we don't, limit definition of a sine. We have, if we're going to use our limit definition of a derivative, vegans, we set up this that I was saying before, and I think I saw you say correctly that we should do a trig identity for that addition. All right, I mean, we don't need to like argue about it. I just take this as an educational, I guess, opportunity. So yeah, if we do our trig identity, that I believe you did point out, vegans. We get sine of x cosine of h plus cosine x sine h minus sine x over h. And I think we want to group up the numerator. Limit as h goes to 0. Sine of x, I'm going to take those two together. Cosine h minus 1 over h. Plus the limit as h goes to 0 of that cosine x sine h over h. And so I'll show one more step, but this right here is the problem for when we're proving this derivative. The sin x will come outside because the sin x doesn't have h inside it. Not x, but h. Cosine of h minus 1 over h. Plus, this cosine can come outside as h goes to 0. Sine of h over h. So that's why. Vegans, because we end up with the exact same limit when we haven't proved that the derivative of sine is cosine yet. So that's why it's wrong to use L'Hopital's on that limit, because we don't know the derivative of sine yet. All right, Sophie. I know what vegans means. Like, English isn't vegans' first language, so we can cut them a little bit of slack here, I think. But yeah, it's the fact that you get that limit there, which is why it's bad form. You want to do sin x times cosine h. Oh, okay, yeah. You're just responding to what two fractions. I don't exactly know how you evaluate that limit, to be honest. Cosine of 0 is 1, so you end up with 0 over 0. That, we've just proven this is 1, so we don't have to worry about that. I expect this to become 0. I don't know why. Is that like the definition? Is that the definition that I'm missing, maybe? This is the derivative of cosine? Potentially? At x equals 0? But then, like, that doesn't really help us, because... Cosine of 0 is 1, though, Jeff. That's why I was thinking, like, maybe that's the definition of a derivative for cosine, but... Wait. Well, we don't know that cosine derives to minus sine yet, right? Wait, which direction is this going? Is that the key? Like that, these two things are equal, aren't they? And cosine of 0 is just a constant, that becomes 0? Or, yeah. I feel like this is a little bit sketchy, but 1 prime is 0, so we just get cosine x. Oh, I wrote the -1 too small. Yeah, sorry, I'm just stuck with my webcam right now. My next math stream, I should have, my setup will be different, I hope. And it'll be a bit easier to see the whiteboard, because I'm not really happy with how things look right now. It's just the thing that I was doing broke, so. If I had to improvise. So I guess I just proved the derivative of sine as well, which is something we had to do anyway. All right. Sophie, Meegans, if you guys want to have that discussion, or I'm sorry, if you all want to have that discussion, like, please feel free to do it. But if either of you just wants to drop it too, just feel free to drop it. I don't mind either way, but I just want to make sure that people don't feel like they're being like they have to do math and they can't just like hang out and try and discuss what I'm doing. What was I gonna do? Proof of derivative of sine. I just want to check my last step there. Oh, really? L'Hopital's rule does apply for this? We haven't... Oh, wait, this might be something fancy, though. Okay, this proof is something that I'd be able to use in the context of this class, I think. What happens with this limit on the right? Okay, I guess I should have done it like this. I don't know. Oh, wait. No, I didn't do it like that. All right. Well, there's at least a non-derivative way to show this limit. It's kind of clever. All right. So I would just erase my board and put this work up there, which I'm not going to actually do, but I'm happy with that. Okay. That was kind of neat. Oh, this one. Wait, have I skipped everything? Okay, no. I was on 8A, but I skipped all the way back to like to day 9 just to revisit the sine of x over x stuff. I could do these other ones down here, but I kind of want to look at this E limit. So this is the definition of derivative at E evaluated at x equals 0. From B, you can see that C and D come from limit laws. Oh, for They do? Calculating D before C? The gamma or the beta being trapped inside the sine. Oh yeah, Peach Tea a little bit. But no, it was just we're talking about why you can't use L'Hopital's for sine of x over x. It's a change of variable? Oh. I see why D is much easier. Okay. Yes, if I was thinking like, well, if C you get beta, then why wouldn't D be 1 still? And if you just treat it as a change of variable, you still get 1. That's cool. We were going to talk about changes of variables today in class too. Well, I think B, you still can't do Taylor series because you don't know the derivative of sine, and Taylor series relies on the derivative. For arc sine, I don't know. What's by numerator and denominator by beta? Oh, I see, Jeff. So you get beta times the limit, and then it matches this form here. Okay. Also, I don't even feel the need to write that on the board. I feel like I just get it. This arc sine limit. What's happening with that? I feel like we should still get 1. That's completely... This is like complete intuition, though. Or like, I guess like an instinct. Make an arc that taking sine preserves the limit. What's that, vegans? Let me open it up. X equals sine of u. Ooh. That's something. Oh, yeah. So this is another thing. This relies on the derivative of sine. You have to already know what sine derives to do this. Yeah, so like the Taylor series, you have the derivative already built in there. That's the issue with doing a Taylor series also. It's like a famously tricky limit because you have to do it in that weird geometric way. Because your normal solution techniques just don't work. I really like that x equals sine u change of variables, Jeff, for arc sine. I think that's how I was thinking like, you know, if the inverse function is just a reflection around the line y equals x, and the function already like evaluates to 1, so sine of x and y and x kind of approximate each other close to 0, then surely arc sine, a reflection across y equals x, shouldn't change the value of the limit. Just think about it like geometrically and like that, I guess. And I think that's a nice way of actually getting to that result. So if we have limit as x goes to 0, arc sine x over x. Let's do a change of variables with u equals sine x. No? Yes? No, sine of u equals x. Yeah. So that means sine of 0 is 0, or arc sine of 0 is still 0, so this is going to check out okay. So we can say it's the same thing as limit as u goes to 0. That becomes u, that becomes sine u. And I think we have an identity that the reciprocal of the limit goes to the reciprocal of the limit. So the reciprocal of 1 is still just 1. So that's why I think that's a really neat proof technique. So I think you're allowed to just say that 1 over the function goes to 1 over the limit. Oh, there probably is that complex way to do it, SPQ, you're right. So yeah, Jeff, I really like that. And I think that's a save. All right, so we have this definition of E, and we want to 1 plus 1 over n to the n as n goes to infinity. We need to somehow use that. Is that going to be a change of variables in some way? Maybe not. We haven't actually proven the derivative of E yet. That's number 9. Can't. There. I'm not even sure of how you approach this one. Do we need fancy 0 maybe? I don't think so. It's not that I can... part B here. Like, do we just literally wholesale plug in another limit here? Like, have a limit of a limit? I don't really know how that works. Let me look back at our limit definition of E. I want to copy it down on the board just so I can see it. Binomial theorem on the definition of E? Oh! That's interesting. We already did the binomial theorem once for power rule to prove why that works. Wait, n goes to infinity. It's the n. So I guess I'll blindly do binomial theorem on our definition of E and hope that we end up with the limit that we have. So the first term is 1 to the n. I keep on writing 0. N choose 1. 1 to the n minus 1, 1 over n. N choose 2. It's not necessary to write the ones, but... plus dot 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 1 over n to the n. Okay. Wait, 1 to the infinity is indeterminate, though. What happens with that? Like, all the terms in the middle definitely go away. I don't know how you evaluate the terms. Like, you 1 to infinity and 0 to the infinity. We're not given that n is an integer. We're not given that n is an integer. Well, n is just some really big number. Well, actually, the series is infinite. Oh. Oh, that's what you mean. This shouldn't end like this. It just goes off to infinity. That's what you meant by that. Okay, my bad. I still don't know what we do with this. E to the h. I mean, if someone want to get to that's what we want to get to. I don't know where how that helps us so far. And it's never actually infinite? I'll go with you on that, I guess. Why do I keep on writing 0? Well, okay, so anything you choose 1 is always just 1. That's just 1. That's going to be 0. I mean, I don't think the chooses are going to be... The chooses are going to be finite, I guess. The 1 over n is the important part. Does that just come out to be 1? Wait, this proves that e equals 1? This can't be right. I did something wrong. I'm misunderstanding... I'm misunderstanding something, because we definitely can't go from e equals to 1. So something with the chooses, I guess, we can't just get rid of them wholesale. I've seen that n, we're not given n as an integer, so I guess the chooses don't actually... Yeah, I don't know how the chooses work when you don't know that n is an integer. Because I don't think you're supposed to bring gamma into the picture, and I don't know if that would even help you. Huh. So, I don't know if binomial theorem is the right call. I don't know what is the right call. Like, what I want to... Like... This is the derivative value at x equals 0. Like... Okay, what if I just do the ham-fisted thing? Oh, I shouldn't erase our definition. Ugh. I'll just remember it. If I just do the ham-fisted thing, and I start with h goes to 0, e to the h minus 1 over h. So I want to take that. I'm just going to take that E and plug in our definition again. Like, how does that look? Horrible. Okay. Does that do anything for us? Oh, sorry. Was that actually right? I was kind of thinking that might not be right. Or like, if n is an integer, how do you do factorial of something that's not an integer besides the gamma? Hey, Keshar over on YouTube. So it's not from a book. It's from a real analysis class that's being taught live on twitch.tv. And I keep forgetting to update this command. It's actually about to start again in 15 minutes. I need to get Zach's link. Over at this Twitch channel. And so this is a problem set that is from that class. This is all about real analysis as well. It's a real analysis class. I should have said that. Binomial theorem on integer exponents is simply that. Oh, okay. We did use it to do this. So, I mean, we haven't actually proven it or done anything with it until today, but we did use it the once at least. So I think binomial theorem is fair game. Hmm. Shoot, I kind of regret erasing it. I assume we're going to need this fact down here to do the derivative. Let me just read what you said. Next up should look like limits n goes to infinity, 1 plus n times 1 over n. That's 1. N times n minus 1 over 2 factorial? Oh, for choose. Times 1 over n squared plus n minus 1, n minus 2 over 3 factorial. Plus 1 over n cubed. Oh, and the degrees on top and bottom are always the same. It's going to come out to be like the power series, isn't it? With an extra 1. Okay, well, let me rewrite that then. I didn't realize, I thought it was just wrong, so I was like, oh, okay, let's just erase it. So binomial theorem. N choose 2, 1 over n squared, plus dot dot dot. So that's just 1. So n choose 1 is just n, and n over n is also just 1. And then here we have to get our limits again. I do want to verify my binomial theorem. Okay, it is n choose k. And how do you... And, okay, let me just copy down this formula because I can never remember it. Okay. So n choose 2 n factorial over 2 factorial n minus 2 factorial? And that comes out to be, okay, so that's where I get it. 1 plus 1 plus, because we get the factorial cancellation, n minus 1, 2 factorial, times 1 over n squared. And so the degree on top there is equal to the degree on bottom. So it's a little, we haven't actually shown this, I guess. Well, we did. It's going to be 1/2. Or, you know, it's going to be 1 over n factorial. So actually, I'm still not sure how we get to there, though. We have a power series for E. Oh. Okay, fair enough. I could bring the 1 inside that series as well. Wow, so just doing a power series without even knowing the derivative, that's kind of crazy. Okay, so we know that E is equal to this. I'm going to write it as 1 plus sigma n equals 1 instead to infinity. Actually, this works for n equals 0, right? Yeah, because 0 factorial is still 1. Maybe we do want the 1, though. So we can leave that as it is. Hey, Brian. Since h is independent of n, you can set e to the h inside the limit as n tends to infinity. 2 power series for e to the h pretty quickly. So like you can get all the way into like 1 plus 1 over n to the h to the n? Or maybe that's taking it too far. I guess you can get it so that like the entire thing is to the power of h. I'm not sure if I completely understand that. Binomial theorem again. Equivalent by definition of E by Taylor series. So this is a prompt from later on in today's class, OB. So the only task was to prove this limit, and I was following a path that Sophie was saying with, you basically get the Taylor series for E without ever deriving anything, which I didn't know was possible. Just using the binomial theorem. No, we have the limited definition of E, and we're trying to prove this identity. And I think it's going to build up into proving the derivative of E is itself. But we're not at that part yet. F of x equals e to the x implies f prime 0 using 0, 1, and h e to the h. It's also h minus 0 on the bottom. Yes, well, I noticed it fits the definition of a derivative. Oh, is that what you're saying too, Brian? But we haven't shown that the... Well, is it just e to the 0? It's breaking the graph, PhD. Oh, to the NH. Okay. And so NH, and then it's the same exact thing. Really? A to the H, NH. And then what's doing what? The exponent. I think the choose needs to change, doesn't it? Subadding with the binomial theorem. Okay, so the thing on top in the choose is the exponent. Okay. Like NH and H like that? And then we need to change up our chooses? Well, NH choose 1 is just NH. That one shouldn't be there then. It's 1 over n, which is going to be just h plus nh factorial over 2 factorial nh minus 2 factorial times 1 over n squared plus 1 plus h. My n's and h's look a little bit too similar. That is an h though. So that's going to be h over n factorial. I keep taking the first term out. N equals 1 to infinity h over n factorial. Okay. And this is actually a lot simpler to plug in now. Okay. Thank you for pointing that out, Sophie. Because or at least this will, the h can come up front of the summation too. Like there. So now let's try plugging into the limit. 1 plus h n equals 1 to infinity 1 over n factorial minus 1 over h. Okay, the 1's go away, the h's cancel. You just get sigma n equals 1 to infinity. Oh, well, is that equal to 1? It shouldn't be. What did did I do another thing wrong? That's NH factorial. No? Wait. No, that is n factorial. It's just a different n. I'm mixing my n's. It's not. I used n for my index, which. Wait. I need to think about this more. This becomes nh times nh minus 1. So is this h squared? It's not... I think I jumped the gun. I think that is h squared. I don't... That doesn't fix everything yet. We do get nh times nh plus or minus 1, so you do get h squared n squared. All right, see you, Sophie. Thanks for your help with this. Spoilers, Anders? No, I would never have thought to use binomial theorem on this, so... I'm doing something wrong still. I mean, what would this buy us? Actually, it's h to the n, not h squared. H to the n. Oh my god. Okay. So I think these first two terms still work in the pattern. So limit as h goes to 0. N equals 0 to infinity, h to the n over n factorial minus 1 over h. What the heck is this? Do I want to start my... Like, we could cancel the h with the h. We'll get -1, though. We want +1. No, we don't even get -1. I don't know. I think I can't quite bring that one home, but it's 6:30. I assume that the real math class has started, and I don't really want to run into class time here. It just started? All right. Oh, yeah, I see. All right, so let's go right out to Zach. If you're on YouTube, thank you for hanging out with me. I appreciate you, whether you're chatting or lurking. And I'm going to cut the YouTube stream off here, so I'll see you around.